Yes, sir, we are live now.
Okay, okay. Hi, Steven. Good morning. So, Steven will just wait for others also to join. We'll wait for a couple of more minutes before we start. Great, great. Yeah, yeah. I usually what I do is I also share, in one of the classes some of the premium sources. If someone is more interested, right, in building knowledge, so I share some, links, some good books, some good websites, and if you want to further build on your understanding on this subject, you can go through them. I'll be sharing that in the next session, the final session. Yeah. So Stephen, while I see others also joining. Hi Anu, hi Pallavi, hi Sumit. Good morning. Hi Pratiksha. Okay, so it's 10:32. I think we can start now. Okay. So I see all of you were there, right, in yesterday's session as well. So this is where we left yesterday's evening discussion, right? So what we did was we spoke about what time series is. So maybe we can go 2 slides back, right, to see where we. Let me just get the pointer. Okay, so let's. Right, so this is what we started our conversation with. So we said a time series is something which is observed sequentially over time, and when we talk about forecasting a time series, we want to see how these observations will continue, right, in the future. And we also saw that any time series typically has got 4 components. So if this is a time series, we can decompose the time series into trend, into seasonality, into random noise, and fourth component, which is not shown here, the cyclicity, right? And we said that there has to be 2 conditions pre-met before we even start forecasting a time series. So one is we should have enough data in past, the high quality data in past, to be able to pick up patterns. And when we talk about patterns, we mean trend, we mean seasonality, we mean randomness, right? We mean cyclicity. And if these patterns are repeatable in nature, if we can make that assumption, then forecasting will make sense, right? If if past is not going to be something which we can depend on to forecast future, then forecasting is not going to be useful, right? And then we looked at few examples of different organizations wanting to forecast, right? And each of these situations was very unique, very different, right? So some of them had time series, or some of them had businesses which were affected by trend, which was affected by seasonality, sudden spike in demand, sudden drop in demand, right? Some of the businesses driven by halt. For example, we were looking at one of the cases of estimating the weekly air passenger traffic, right? And here the number of drivers or number of extrapolatory variables which can impact demand or estimation are quite high, right? So these are school holidays, sporting events, advertising campaign, competition behavior, right? And the difficulty here was that school holidays are not coinciding, right? At a city level, school holiday happened during a different time period, right? Similarly, sporting events are also not happening in one place. They also tend to shift places or move places, right? So it all makes prediction difficult. So for all the situations, for all the different businesses that we had discussed yesterday, models are going to be different, parameters are going to be different. A good model will be the model which will be able to take into account all of these nuances of the business and be able to throw a forecast, be able to give a forecast out in the future period, which is, and I said there are certain characteristics of a forecast, right? While the important or main KPI of a forecast is to be accurate and under control when it comes to bias, but there are other aspects that I have been mentioning, right, in my lectures, that forecast has to be reasonable, forecast has to be the one which can be trusted, right, and forecast has to be one which can be explained, right? Now, all these three things doesn't come naturally when you talk about only accuracy and bias, right? A forecast could be 80% accurate, but if it is not being trusted, if it is not being explained by the analyst or by a forecaster, right, and it is not reasonable, right, uh, I mean, the consumption or the usage of forecast could be a big question, right, Mark, in the organization. So one has to ensure, and you would have seen in yesterday's discussion that when we were talking about a prerequisite of a forecasting process, it was just not the inputs, it was not just the data alone, it was also about the process, right? How is the process designed? How effective the process is, which is consuming, which is getting the data, which is, generating the consensus, and finally creating a buy-in from all these stakeholders in following that forecast. Okay, so these are all very important ingredients, and if you miss out on one of these, right, the effectiveness of the whole forecasting process can throw up host of challenges, right? So, so this is what we were discussing yesterday, right? We were about to discuss. So we are going to look at some of the specific methods, right, under quantitative bucket, right? So yesterday we saw there are broadly two ways of generating a forecast. So one is qualitative, second is quantitative, and qualitative is largely meant for some specific use cases, right? Wherein data is not there, wherein we're talking about new launches, wherein data is there, right? But data is not sufficient in itself, right, to give a good forecast. So you need to build qualitative input from sales, marketing to enrich your forecast, right? We also discussed a situation when your forecast is only at a 10% growth, right? Because it is dependent largely on historical sales, but your organization wants to grow at a 30% growth, which is three times of the normal growth, right? So without qualitative input from various stakeholders, right, it is difficult. We also saw that qualitative is not equal to guesswork. It's a very structured way of generating a forecast, right? And at the same time, if you have enough data, if you have high quality data, right, you can use some time series methods, which are largely the methods which involve statistics, right? Simple statistics, complicated statistics, to basically get the forecast for the future, right? Now, some of the standard methods which are being used, right? And you would have seen in one of the case studies, case one, we saw that how organization who is into the manufacturing of tableware was using, different methods of generating a forecast, right? And all of these are statistics based method, right? So average of last 12 months, 6 months, regression over 12 months, 6 months, right? And all of these. So similarly, when we talk about some standard methods, right, which a forecaster or which a demand planner or which a data analyst or business analyst can deploy to generate forecast in future, right, are these. So first method is called as naive method. Second is called as simple moving averages. Third is simple exponential smoothing. Fourth is double and triple exponential smoothing, and fifth model is ARIMA, right? So while you will see lot of other combinations also, lot of other possible combinations also when it comes to time series, but when we are trying to understand the basics, let's first keep it simple, right? So from the scope point of view, if you will see in your async content, in async only simple moving average and simple exponential smoothing is being covered. So there is no mention of double and triple exponential smoothing. And I will just mention here because you should be aware that and actually I think there's a typo here, so I'll correct it later on. But read this as a single exponential smoothing. Okay, it's not simple actually; it's single exponential smoothing, and then it is double exponential smoothing, and there is another triple exponential smoothing. Okay, so we will only be covering simple moving averages, single exponential smoothing, and ARIMA, while it is mentioned in the async content, but it is covered at a very top level or at a very broad level. So we are not going to discuss any example or such. We will just mention what ARIMA is about, right? And in async, there is no mention of naive method also, but it is very important to understand naive method, which I will explain. It's very easy to understand, but you should know, right, what naive method means, right? Now let's look at one time series, right? So what you see here, right? So your y-axis is the passenger load on a certain airlines, weekly passenger load, and this is in thousands, right? And what you see on the x-axis is the year mentioned, right? So now you can, if you look at this time series, right? So we can see, the time series depicting a lot of stuff, right? So there is a trend, overall trend, right? You can see there are a lot of spikes and troughs, right? You can also see, a certain period between 1989 and 1990, wherein, there was a sharp drop in the weekly passenger load, right? And then it sort of, went on to increase to a certain level. And then again, we see between 1992 and 1993, right? This dropping, right? Now we are talking about, choosing or working with a model, right? A time series model which can explain these drops, right? Account for trend seasonality, right? So if, let us say, somebody were to work on such a time series, right? They need to understand, right, what are the key root causes or what are the key explanations for these spikes and troughs in the past, right? So let's see, right? So these are these time plots, right? So I have got a example wherein some interesting features are already mentioned, right? So, and why I'm taking this example again is for you guys to, fully understand that whenever you are trying to predict a time series, right? Try to get as much information, try to get yourself as educated as much possible about what has happened in past, what has led to such a time series, right? And if you are in hold of some crucial information, it really helps you fine tune your forecast, right? And let's say if you don't have any information, any qualitative information about why a time series looked like this, and you go about forecasting the weekly passenger load for next few weeks, right? And you get a certain weird forecast, right? You will not be able to understand or explain why such a forecast, right? So you need to know, because your future forecast is all coming from your past, right? So model is trying to figure out the trend seasonality, and if model finds something weird in past, it will try to throw that up as a noise in future as well, right? So let's see, so what are some of the observations, right? If somebody was a planner or a good analyst, he would have got all of this information, right? When he would have made efforts from different stakeholders to ask, right? So there was a period in 1989, right? We were talking about this. So there was a period in 1989 when no passengers were carried, right? And this was due to an industrial dispute, right? So we can attribute a reason here. We can label, this part of the time series to say that there was no passenger load in this time. It was zero because of an industrial dispute, right? Now there was a period of reduced load in 1992, right? So we see a sharp drop here as well, right? This was due to a trial in which some economy class seats were replaced by business class seats, right? Then a large increase in passenger load occurred in the second half of 1991, right? So we can see a, going trend, right? Which is not sustaining, right? It went up for a time and then it is tapering down, right? So it's an increase, but there's no reason, right, mentioned here. There are some large dips in load around the start of each year, right? Now this is a very subtle observation, right? So what they've observed is that around the start of every year, are some large dips, right? These are due to holiday effects, right? There's a long-term fluctuation in the level of the series, right? So level is certain level, right? Which increases during 1987, right? So level increases, decreases around 1989, and increases again between 1990 to 1991, right? And there are some periods of missing observations, right? So for example, here there is a missing observation, right? So this time series, right, is a example of all the cases, right? Increasing trend, decreasing trend, right? Missing data points, a sharp drop, right? The point here is, if a time series is so complicated, right, what would a good model look like? Any model, good model will need to take all of these features into account, right, to effectively forecast the passenger load into the future, right? So while we are talking about these methods in isolation, for example, we'll talk about naive method, simple moving average, single exponential smoothing, double, triple ARIMA. But whether one of these models would be able to give you a good forecast, or double, triple exponential smoothing would be the one, or regression would be the one, right? It has to be done basis test and trial, right? Or basis the expertise of the statistician or an expert forecaster who has worked with similar time series in past, right? So before we move on to simple moving average, right, like I said that in your async content, there's no mention of naive method, right? So when, let's say, you are a planner or you are a forecaster or analyst, data analyst, supply chain analyst, and you are given this time series to be forecasted, right? Now, one way is that you right away, launch yourself into experiment with a very complex method, let's say ARIMA. You say, I'm going to start with ARIMA, right? Now, using ARIMA will require certain effort, right? You will have to get the right data, you will have to fine tune model parameters, you will have to do a lot of experimentation, right? And it is going to take some time and some effort, right? And eventually, let us say the accuracy that you are getting from this model, right, comes to around 30%. Now you will be disheartened and you will say, okay, I've used an algorithm, I've used an approach, I've used a method, but the accuracy that I'm getting is only 30%, right? Now somebody said, okay, try using simple moving average, right, which is to take an average of n number of data points in past, right? So, okay, you said I have not used that approach. For some odd reason, you straight away went to ARIMA. But now when you experimented with simple moving averages, you found out that your accuracy was 60%, right? So the point which I'm trying to make is, sometimes, there will be certain analysts, sometimes there will be certain, data experts or modeling experts who will first try with the simplest method available and try to create a baseline. What is the baseline? So they will first use a very simple method to say that if I were to not invest any effort, if I were to not do any complicated stuff, what is the minimum accuracy that I can get from the simplest of the technique available? So first they try to create a focus out of a method called as naive method. Naive method is the most simplest method, right? Now what could be a naive method? Naive method could be, you may say the next month forecast is going to be equal to last month actuals. Is there an effort in generating a forecast basis this? If you use such a simple method that my next month forecast is going to be equal to my last month actual, is there going to be an effort? It's a very simple method, right? Equating next month forecast, right, to your last month actual, right? Hello, are you guys with me? No efforts, right? So let's say my last month actual is 100, and if somebody asks me, okay, what is going to be your next month focus, I will say 100. Okay, now I'm using a naive method, right? Now let's say when I look into actuals of next month, which I had forecasted to be 100, my actuals are actually 90. So what is my forecast accuracy with this method for next month? 90%, right? Yes. Now let's say if I would have used a very sophisticated and a complex method, machine learning or ARIMA or whatever, and my forecast would have been, let's say, 200, but my actuals are only 90. So my error is, my forecast is almost accuracy 0, right? So in this case, my naive method has outperformed my any other complex method, right? So basically, and it is not that the definition of naive method is only this, which is next month forecast equal to last month actual. You can use any simple definition. For example, your next month forecast is going to be equal to last year same period. What does it mean? So for example, my next month is March. My March forecast is going to be equal to my last March actuals. My next April forecast is going to be equal to last April actual. my next May forecast is going to be my last year same period, which is 2021 May actual, whatever it was is going to. So that is again a very simple way of generating a forecast, right? So all of these very simple methods are called as naive methods, right? So what planners do when they are modeling any time series or when they are doing any analysis for forecasting, they first use a very simple method to see what is the baseline accuracy that I am getting. So let's say when you use a naive method, which is my forecast for next month or next to next month is equal to my last year same period actual. When you generate forecast this way, and you find out that your forecast accuracy from this method is coming to 80%. So you know that even the simplest method is giving me 80. So your justification of using any complex method beyond naive method will only come when it is giving more than 80% accuracy or 70% accuracy. Is it clear? Why you are using ARIMA or why you are using double triple exponential smoothing can only be justified if the accuracy from these models are better than naive method. Is it clear? Okay. So now let's move to another very simple method, right? Sometimes you can call this method as a naive method because this also doesn't require a lot of effort or lot of brainy stuff, right? And what we are talking about is simple moving averages, right? And we are very comfortable with working with averages, right? We know how to calculate averages in Excel also, right? And it doesn't need that much of effort, right? But here the word is moving average, moving, right? So what we need to understand is what is meant by moving averages, right? So let's look at what this algorithm is. Okay. So what is a simple moving average? So a simple moving average is the simplest, very popular forecasting technique, right? Based, and the principle is same, right? For all time series. What? That past is the estimator of the future, right? Here only meaning is that near past, right? When we talk about simple moving average, the variable is for of how many months you are going to take an average, right? So there is a variable called as n, right? So basically, when you talk about SMA, sometimes it is called as SMA. So you put a hyphen and then put a n. So you may define SMA2, SMA3, SMA4. So this 2, 3, 4 are nothing but these are the periods in past over which you are going to take an average, right? And it's called a simple moving average because this window of 3 or 2 keeps on moving, right? With every timestamp, you move this window a little bit ahead, right? So in simple moving average, the prediction for a timestamp is the average of its previous and timestamp observations, and the n is called as the moving window. And we'll look at one demonstration also to understand this, right? And the inference is the moving average captures the trend of the data automatically, right? And what it does not do is capture the seasonal effects, right? Because for any algorithm or for any model to capture seasonality, it needs a certain number of data points, right? So if you're talking about, let's say, a monthly seasonality, right, you need to have 24 data points to capture the seasonality which is present in the data, right? So what you're seeing here, right, as an example, are some set of data points, right? So timestamps are given. So month 1, month 2 till month 18 months, and what you see here is the actuals, right? So 1104 units, or unit of measurement is not there, but you can understand that 1104 was the actual for month 1, 885 for month 2, and likewise, right? And now we want to understand how simple moving average work, right? So here we are first talking about a simple moving average 3, right? Which means that the next month forecast is going to be a simple moving average of previous 3 months. Are you getting that point? Yeah. So right? So how many data points in past would you need to calculate the simple moving average? How many minimum number of points will you require to calculate, right? So here what you can see is that these are the 3 points, right, which we have to by default start with, right? Because it's a simple moving average, right, which involves average over 3 data points, right? So we first keep the first 3 data points actual as it is, right? So 1104, 885, and 976, right? Now, if I have to calculate the forecast for this month, right, it is going to be an average of these three data points, right, which comes to 988, right, while the actual was 1101, right. So you can see that the error is not that much, right. So if you had taken a simple moving average of these three data points and generated a forecast, you would have got 988, right. Now let's say you have to calculate the simple moving average. You have to calculate the forecast for fifth month, right. What will be the three data points that you will consider, and can you calculate the average? So the points, what data points will go into that? So I am also calculating with you. What three data points will be considered? Vinay, can you mention the values to calculate forecast for period number 5? What three data points will be considered? Okay, 885. Okay, so that is what I was, I was worried about. So Sumit, it's a wrong answer, right? So Sumit, you said 885, you said 976, and you said 988. You cannot take 988 because 988 is the forecast. You have to consider the actuals. So when you are forecasting for fifth period, you have to look at the actuals of last 3 months. So you have to take an average of 885 plus 976 plus 1101 divided by 3. So what you will get is 987. But the actuals was for fifth month was 1120, right? Then if you have to calculate the forecast for sixth month, you will take actuals of period 3, period 4, period 5, calculate an average, and it will be 1066, right? So you can see first you had considered an average of these 3 months, right, to get a forecast of 988. Imagine a window here, right? So imagine a window here. So this was the first window. Then the window slided. So then you had taken these three data points. Then window slided further. So you had taken these three data points. Then window will slide further. So this window of size 3 is moving, right? As you are calculating the forecast for next month. Got it? Right? So the simple moving, this was an example of simple moving average, right? For 3 months. Similarly, you can calculate simple moving average 2, wherein you will need 2 data points. You can calculate simple moving average 4, wherein you can start with averages of 4 points, simple moving average 5, right? So this is a very simple method, right? Which will take into account some of the recent months and give you a average number, right? Similarly, see example of a simple moving average 5, wherein the window is now that of 5. So you will have to start with 5 data points, right? Right. Okay. So now we come to the second method. This method is called as simple. Okay. So here also it is written as simple exponential smoothing, but popularly it is called as single, right? And I'll explain why it is called a single exponential smoothing, right? Now, what is the difference between the taking simply averages, right, over a certain window, or doing a smoothing, right? And when we use a term called a smoothing, basically you are talking about a weighting factor or a parameter, and you are taking weighted averages, right? So let's look at this method. So the time series is same as that of this, right? So we are working on the same time series and are using different methods to calculate the forecast, right? So we will work on the same time series, and we will see how do we use the single exponential smoothing to calculate a forecast, right? Now, what is the definition in exponential smoothing, right? The prediction, how do we calculate predict? It is the weighted number of results from before, right? So if you see this method, right, was there any differential weightage that you have given to value number 1, value number 2, and value number 3, or you have considered their contribution, equal contribution in the prediction of point number 4? Have you given more weightage to one month 1 value or month 2 value or month 3 value? No, right? So equal weightage, right? That is why you are taking an average, right? So there is no differential weightage being given to last month, which you may say, okay, that is my latest month, recent month, and I would want to give that month a more weightage than giving, and give less weightage to month number 2 and month number 1 values, right? So here we create a differentiation, right, in exponential smoothing. So it's a weighted number of results from before, right? And it includes a single parameter, which is called as alpha. And this alpha is called a smoothing factor. And so that is why, what is a smoothing factor? Smoothing factor is nothing, but it's a weighted factor, right? Now, this smoothing factor, it can take certain values. And what are the values? The values are always between 0 to 1, and it controls the rate of exponential decay. Now, what is the meaning of exponential decay? That it tries to give less and less weightage to the data points which are in past, right? So for example, I am trying to calculate a forecast for, let's say, point number 4. It will try to give more weightage to 3, less weightage to 2, less more, and even lesser weightage to 1, right? So the weightage is decaying, it is reducing, right? And how do we control this decay rate? At what rate? It could be that we give 90% weightage to point 3, and then less than 10% weightage to point 2, even lesser than 10% weightage to weight 1, or we may give 70% weightage to 3, right? So the rate at which the importance will decrease of these data points in past is controlled by this parameter alpha, and this called as smoothing factor, right? Now, if the smoothing factor is large, so large alpha value means that the model focuses primarily on the recent data, the example which I was giving, right? So if you select alpha as 0.9, and it can take value between 0 and 1. If you keep alpha as 0.9, which means that whatever is your previous month data, that you are trying to give 90% weightage, and then for the rest of the other periods, it will get split. All of them will have to split that 10% weightage, which is more or less saying that I don't care, or I don't give a lot of importance to what has happened beyond my last data point, right? Now let's say if you select alpha to be 1, what will it become? If alpha becomes 1, what this model will get converted into what? Yes, so Joginder is right, same as last period, which becomes our naive method, right? Which becomes our naive method, right? Is it clear? If alpha becomes 1, then your forecast is equal to your last month actuals, right? Is it clear? Okay. So now let's look at the formula, right? When we use exponential smoothing, and notice this carefully, right? So forecast for the current period, right? So forecast for the current period is equal to alpha into last period sale, right? Plus 1 minus alpha of last period forecast. Is it clear? So alpha of last period sale plus 1 minus alpha of last period forecast. Okay. Now let's look at two scenarios, right? Let's look at two scenarios where we have selected alpha to be 0.8, and in another case we have selected alpha to be 0.4, right? Now we have to obviously start with month 2, right? Because we need at least one data point, right, to calculate the forecast, right? Now what will be the forecast for period 2, right? So let's say if we have to calculate, so as per this formula, which is alpha of last period sale, so 0.8 into period 1 sale, right? What is period 1 sale? In this case, what is your previous month actuals? 1 second. Huh? Right. So, yeah. So, your forecast for period 2, which is this, is 0.8 into period 1 sale, right? So, what is your period 1 sale? 1104, right? What is your period 1 forecast? Right. So we have to assume forecast equal to sales for the first period, right? And then if you do 0.8 into 1104 plus 0.2 into 1104, what you will get is 1104 for period 2, right? In both the cases, right? So 80% and 20% become 100 and 40% and 60% becomes 100, right? Now let's try and calculate the forecast for period 3. So for the forecast for period 3, right, is going to be as per the formula, right? In this case, 0.8 times 0.8 times your period to sale. What is your period to sale? What is your period to actuals? 885. Good. And what is your period to forecast? 1104, right? 11. So right. So if you talk about the single exponential method, so what is happening for period 3 in when you are selecting 0.8 as a decaying factor or as a smoothing factor? So period 3 will be 0.8 into your period to actuals, which was 885, and 20% weightage to your period to forecast, which was 1104, right? And if you calculate this number, what this number comes to? It will come to 928.8, which is shown here as 929, right? It is rounded off. Similarly, if you were to use 0.4 as a seasonal, 0.4 as a factor, right? So here it will become 0.4 into 885, right? Which will become 0.4 into 885 plus 0.6 into the forecast. So it is giving more weightage, right, to the period to forecast, right? And what will be that number? Exact number can someone calculate? 0.4 into 885 plus 0.6 into 1104, right? And that number comes to 111016.4, right? Which is rounded off to 1016. Is it clear? So this is called a single exponential smoothing, right? Wherein you are giving a certain weightage, right, to your previous month sales and a certain weightage to your previous month forecast, right? Okay. So this is called a single exponential smoothing. And like I said that there are other two methods also, right, which are not mentioned in your async content, but you can explore if you're interested later on. So there is called a double exponential smoothing and there is called a triple exponential smoothing, right? So here alpha is the first factor, right? Those and those techniques are, I mean, they are similar to this. It is just that you get to play with two more factors, two more exponential smoothing factors, which are called as beta and gamma. Okay. So when in the triple exponential smoothing, you're talking about alpha, you're talking about beta, you're talking about gamma. And basically in triple exponential smoothing, you are decomposing into three elements. Hi, am I audible and visible? Okay, I think there was some network issue. Pranjay, we can continue, right? Hello. Okay, okay, okay. Okay, so this is single exponential smoothing, right? And I was referring to double and triple exponential smoothing, wherein you get more smoothing factors, right? So here we are only talking about alpha. In double exponential smoothing, we talk about alpha, beta, and in triple exponential smoothing, it becomes more complicated, and we talk about alpha, beta, and gamma, right? And depending on the series, the time series that you're working with, if it has got trend, if it has got seasonality, right? So when I think so here, bigger value of alpha closer to one means giving more weightage to the last data point. Is it that? And how do we decide? Yes, yes. And it depends, right? So if you think in the business, like I mentioned earlier, that if you think your recent period is more relevant, right? And your data becomes obsolete very fast. So you can choose to give less weightage to your other historical data points, right? So the value of alpha has to be driven through test and learn, right? What alpha gives you the best forecast accuracy, even that can be automated, and most of the time it is automated, right? And the model select itself the best value of alpha which gives you the maximum forecast accuracy. Clear? Yeah. One second. Okay, just give me 1 second. There's a little bit of yeah. Okay. So just a question here, right? So if you see the definition of simple exponential or single exponential smoothing, it is written here: the prediction is the weighted number of results from before, right? And it includes a factor called as alpha, right? But if you look at the formula is that the forecast for current period is equal to alpha of last period sale plus 1 minus alpha of last period forecast, right? So my question to all of you is that here everything is dependent on what happened in the previous month, right? What was previous month actual and what was previous month forecast. So for example, when you were calculating, let's say period 3 forecast, which is 29 here, you multiplied 0.8 by actual of period 2 and by forecast of period 2. But what about period, for example, if you look at, let's look at period 5 forecast, right? So what is period 5 forecast? So period 5 forecast is 0.8 into period 4 actual, right? And 0.2 into period 4 forecast. But we are not taking into account what happened in period 3, period 2, and period 1, right? But here we are saying that in single exponential smoothing, it gives a more weightage to point period number 4 value, less weightage to period number 3 value, even lesser weightage to 2, and even lesser weightage to 1. But when we look at the formula, when we are calculating the forecast, which is 1074, it is dependent on actual of week 4 and the forecast of week 4. So where is week 3, week 2, and week 1? Can somebody explain? Just take 30 seconds. Okay, will anyone be able to explain what is the difference here? Yes, so Joginder is right, right? So he says that week 1, week 2, week 3 exponential decay is captured in the week 4 forecast, right? Let's understand this a bit, right? So what we are saying is week 5 forecast, which is this, we are trying to calculate this number, right? Week 5 forecast is equal to week 4 into 0.8, right? So we have given 0.8, which is 80% weightage, 80% weightage to 1101, which is week 4 actuals, right? And then what we had done, we had given 0.2, which is 20% weightage to this period forecast, which is 967. Now, can somebody tell me what is 967? What, when you do 0.2 into 967, are you not doing 0. What is 967? 967 was 0.8 into 976 plus 0.2 into 929. Was 967 not this 0.8 into 976 and 929? 967 had a component of week 3 actuals and week 3 forecast, is it not? This number 967, which you had given a 20% weightage, this 967 had a 80% component of 976 and 20% component of 929, right? What is 929? 929 has a 80% component of week 2 actuals and 20% component of month 1 forecast. What is 1104? 1104 is a 80% actual of one month number 1 and 20% forecast, which is equal to actual. So if you look at 967, it is coming from nothing but from the actuals of 3, 2 and 1. Is it not? Is it not? Right? So indirectly, when you say that you are multiplying 0.2 into 967, you're actually multiplying 0.2 into 0.8 of 976 plus 0.2 of 929. If you further decompose 929, it is 0.2 into 0.8 of 885, right? So you will see that there is an exponential decay which is happening in this process, in this formula. Does anybody need more explanation? We can pull out an Excel and do this exercise. Or is it clear? Is it clear? That this clear, right? This 967 is nothing but it is all made up of week 3 actuals, week 2 actuals, week 1 actual. It is just that the weightage is automatically decreasing. So 967 is nothing. So what you have done is you have done 0.2 bracket, try and imagine 0.2 into 0.8 of 976 plus 0.2 of 929. Now this 0.2 of 929 is 0.2 into 0.8 of 885 plus 0.2 of 1104. And there is a 0.8 factor sitting outside to get multiplied, right? So that is why it is called as exponential smoothing, and the smoothing factor, decreases as we go way back in past. Okay. Now, third model, which we said that we are only going to look at the definition because it is the most it is also called as Box-Jenkins method, right? Box-Jenkins methods. It is called as ARIMA, which is auto regression, right? Integrated moving average model. So auto regression, integrated moving average, and it is one of the most complex method which is available in time series, and sometimes it even beats some of the good algorithms which are there in machine learning, right? So ARIMA is a predictive technique, right, that uses time series to forecast the future. There are 3 elements in the ARIMA model, and most of the time it comes as a standard algorithm in the planning platforms, right? So there's an auto regression, there's an integrated and moving average data, right? So it, when we say auto regression, it basically auto corrects its previous deviations, right? So if it has, let us say model has been forecasting for a few weeks or few months, and model knows that I have been generating a certain error. So by looking at the error, it will try to correct its next month output. So it learns from its mistakes, right? It mimics some behavior of machine learning model, right? So ARIMA effectively autocorrects its own previous deviations, right, from its mean data on the time series part of the data. It is very effective when the time series have trend, seasonality, see here you can see the word cyclicity, right, which I was mentioning earlier. So ARIMA takes care of trend, seasonality, cyclicity, right, to generate forecast. Now, one important limitation of ARIMA is the mammoth data requirement that it needs to generate a meaningful forecast. So one important consideration for ARIMA is that the data should have at least 36 to 40 data points. Right? So if you're talking about monthly forecasting, it is saying more than 3 years of data you should have with stable data, which means that you have to minimize the outliers before using ARIMA, right? Because if there's a lot of disturbance in the data, then this model possibly will not give you the desired results, right? So it's not that easy to implement, right? And most of the times, ARIMA model is seen as a last resort. If let us say naive is not working, simple moving averages or your single, double, triple exponential smoothing methods are not working, then modelers or forecasters resort to ARIMA model. Okay. So now we come to KPIs, right? So if you look at this time series, which we were, trying to forecast, right? So this we had seen, so we had calculated simple moving average forecast, simple moving average forecast over 3 month window, 5 months window, right? 2 months window. Then we calculated single exponential smoothing with alpha as 0.8 and with alpha as 0.4, right? And each of these models, right, what are they trying to do is to predict the forecast, right? For these months, right? And you can see, for example, if we look at simple moving average 3, now it need 3 months to start with, 3 months actual data to start with. Now let's look at fourth month, right? Now when you are looking at fourth month, the actual is 1101, right? Or let's not look at fourth month because there's an SME 5 also, which will take into account first 5, right? So let's look at point number 6, which every model has forecasted, right? So if you look at point number 6 or month number 6 estimate, the actual is 1276, but from simple moving average 3, your forecast is 1066. Your simple moving average over 5 months window is 1037. From simple moving average 2, it is 1111. From SCS, single exponential smoothing 0.8 as alpha factor, your estimate is all same as that of estimate 2. And your simple single exponential smoothing 0.4 is giving 1072. So out of these 5 predictions coming from different models, which prediction is more closer to 1276 as an actual? Which prediction is more accurate? SMA. Okay. Right. So what we have done is maybe you have calculated the gap between the forecast and actuals, right? So when we talk about, let's say, which model is more effective, right, in forecasting this particular time series, is SME3 more effective, or SME5 effective, or SME2 effective? So basically you have used 5 models, and now it is time for you to tell, let us say, your client or your business, which of these models is the best model, right? And you cannot give this answer by looking at only one period. So you cannot say, okay, month 7 or month 6 is best predicted by SMA2, hence SMA2 is the best model for forecasting this series, right? So when we talk about model accuracy, there are various ways through which you can find out which model is the best model for forecasting this type of time series, right? So these are called as error measurements. Obviously, you will try to select a model which gives the least error, right? So there are 3 key KPIs. So one is called as mean absolute deviation, right? Mean absolute deviation is the simplest, wherein you calculate the net model error as the average of absolute difference of the actual and forecast values, right? So what you are getting here is the absolute differences, right? So for example, there are certain cases, right, wherein let's say, let me take an example, is there a case where the prediction is more than the actual. Okay, let me just see. Right. So if you look at point number month number 10, you're actually 730, but in one of your predictions you have got 783 as the forecast. Right. So what is the difference? Your forecast is, if you do actual minus forecast or forecast minus actual, there will be a difference of sign, right? So what mean absolute deviation means, whatever is the error, you take an absolute of it, right? Positive or negative, whatever it is, right? And then you calculate an average, right? So for example, in case of SME3, your month 1 error is 0, month 2 error is 0, month 3 error is 0 for obvious reasons, because 3 data points you're starting with. When you started forecasting month 4 forecast, you got an error of 113, which is simply subtract your forecast minus actual and take an absolute. So your month 5 error is 133, month 6 error is 210, right? Likewise, you got error. And if you take average of all of these errors, month-wise errors, you get a net error of 142. In SME5, when you get a net error, you get a net error of 174, right? So which model gives you the minimum net error? Out of this, which model gives you the minimum net error? Right? So if you look at mean absolute deviation, you will come to a conclusion that single exponential smoothing with 0.8 as a smoothing factor is giving you the least error, right? When you look at mean absolute deviation uh, as your measure of accuracy, right? Then there is another way of calculating the error, right, which is called as mean absolute percentage error, right? Here you bring in the percentage, right? So percentage, the net model error is the average of percentage of the absolute difference to the actual values, right? So these are the net error, absolute error. But now when we talk about mean absolute percentage error, you will calculate the percentage error. And we had seen yesterday in our discussion, how do you calculate the percentage error? You divide your net error by forecast or by actuals. Actuals, right? So what you will do, for example, in this case, your 113 is your error. So you will divide your 113 by actual, which is 1101, and you will convert all of these into error percentages, right? And once you get error percentages instead of actuals, absolute errors, then you take the average of all of those percentage to calculate your net error. Okay, so let's see in next screen what is being done, right? So see, so all of these has been converted into percentages, right? So what was absolute error here? And you can do your own calculation. So if you, for example, divide 11, let's do this, right? So let us divide 113 by 1101, right? So you get 10 point something, right? Yeah, so rounded off to 10%, right? So in this case, your model error is 10%, right? 12%. So when you take an average of these errors, percentage errors, right? What you get is the 11% error from model 1, 13% error from model 2, right? 9 and 9% error from SMA2 and SCS, right? So if you look at the performance in terms of error percentages, which models have done better? Is it only one model, or is it, right? So maybe because this is rounded off, right? But the answer could still be SCS 8, right? Because if you plot mean absolute to MAPE, right, it may be so that this error percentage is slightly lesser, right? So your SCS 8 could be still a better model when you look at MAPE as a measure of accuracy, right? The third model is mean squared error, right? And what you do here is the net model error is the average of square of difference of the values, right? So what you do is, whatever is the error here, you calculate a square of it, right? And then take an average, right? So let's see the third method, which is mean square error, right? So what has happened is, you have calculated, right, Net model error is the average of square of difference of the values, right? Okay, so these are the squares of the errors, right? When you calculate, okay, and then you take an average, right? Now, if you do this, where is the maximum error that you are getting and the minimum error? Right. So SCS again, when you calculate the square of errors, even in those cases, right, in this particular example, SCS 8 comes out to be the best model in terms of square of errors, right? Okay. So is this clear? Various methods, right? Various ways of calculating the errors. It could be in absolute deviations, it could be in absolute percentages, it could be in square of errors, right? Is this part clear? Okay, so now let's come to causal forecasting, right? So if you remember when we spoke about quantitative methods, so we said that one is simple time series, right? Wherein most of the forecast generation happens from the history data itself, right? So we are only looking at historical sales data and trying to study the trends, seasonality, cyclicity patterns, make use of it with an assumption that all of this will continue in future, and we use certain methods, right, to generate a forecast, right? But if there is a scenario wherein you think that your forecast, or your products have a very important relationship, right, with some variables, right, and you want to incorporate the impact of those variables onto your forecast, then you have to use a different way of forecasting, which is called as causal forecasting, which takes cause and effect relationship into account. You define certain variables, right, in past, you define those variables in future, and what the variables that you had defined in past, you would also have actuals, right? So model will try to find out a correlation between the variables in past and the actuals in past to see whether these variables and actuals have some correlation. Now, this correlation could be positive, this correlation could be negative. In positive, it could be strongly positive correlation, or it could be a weak or mild correlation, right? So various correlations are studied, and basis the correlation, then there is a certain impact taken into account on the forecast. And if you feed that variable in the future period, right, so that impact is overlaid on the baseline forecast to generate a final number. Okay. So like I said, that causal quantitative forecasting, two buckets. So time series, we have seen example of simple moving average, exponential smoothing, ARIMA. In causal, which is to study, right, the cause and effect relationship between one or more variables. There are basically three methods that we are going to look at. So one is called as regression model, second is called as econometric model, and third is called a leading indicator model, right? Now, what could be these causal variables, right? So now these variables which can impact your forecast could be some of the variables which are in-house. What are in-house variables? It could be promotions, it could be media, it could be expansion plans. For example, you are expanding the product in terms of reaching more outlets, you are reaching more cities, right? Maybe you are now wanting to sell your products on e-commerce channel, right? It can also have impact because of some macroeconomic variables which I mentioned yesterday, right? It could be, because of buying behavior, which is changing, or the increasing spend power, right? Purchasing power of the consumer. It could be weather, right? Or seasonality variables, right? It could be festive season, right? So there are certain products which would be selling more in the festive season, right? For example, Diwali time, right? Holy time and all of that. So there could be lot of these variables which can impact the demand of your product. Another important could be the competition activity, right? New launches happening from competition, right? So here they are trying to put an exhaustive list, right? So weather and seasonality, when we say festival, holidays, right? Anything got to do with weather. Macroeconomic is GDP, right? Gas price, unemployment rate, consumer confidence index, right? Now all of these variables don't necessarily is going to impact your forecast immediately, right? For example, most of your macroeconomic variables can have a long-term impact on your forecast, right? For example, GDP forecast. If let us say India projects a GDP growth of 9%, it can have a long-term impact on your forecast and maybe not a very short-term in next 1 or 2 months or 3 months, right? But anything, for example, if you're trying to advertise, on TV, on print, or anywhere else in next 3 months, it can have an immediate impact on your forecast, right? So the lag with which any variable is going to impact your forecast also is very important, right? Now tell me one thing, when you see an advertisement on any product, right, of any product, do you immediately go and buy that product if you really like the advertisement? Do you make an immediate purchase, or you wait for some time, or what do you do? No, right? Or let's say an organization releases an ad in the month of February, are they going to see the impact of that ad in the February sales immediately? No, right? That impact is going to come with a certain lag. Maybe the media or maybe the advertisement which got released in February can have a major impact, let's say with the 3 weeks lag or 4 weeks lag in the month of March and April, right? So certain variables can impact the demand or forecast with a certain lag, right, which needs to be taken into account, right? And like I said, that your organization might have some expansion plans, right? So they might want to go to more number of stores or increase store size, yeah, right? Activities of those sort, right? And your customers, if you, let's say you want to move away from your current targeted segment and you want to expand your segment, right? You want to enroll more customers, right? That also is going to have an impact on your demand, right? But while there will be 100 of variables at play at any point of time, what is what will define whether you will be able to use causal forecasting or not is the access to all of that data, right? And access to all of that data at a required granularity. Now GDP is defined at a national level, and GDP is defined for certain industries and certain products, right? So how will you use that data at that higher level on forecasting? Let us say you are into a business of forecasting 100-gram biscuit. So how will you estimate the impact of a GDP forecast of 9% growth on how your 100-gram biscuit is going to behave, right? So it is very difficult to size the impact of a macroeconomic variable at that level to a level at which you are forecasting, right? So causal forecasting becomes difficult on account of not having access to the data, even access to the data, but the granularity at which you need the data to incorporate in the modeling is most of the time not available. Okay, so let's first look at regression method, right? So what is regression method? So regression is one of the most common techniques, right, used to understand a variable relationship in a data set. The best fitting curve is obtained from an independent variable information by regression method, right? So for example, if you look at, so this is a correlation between the rainfall, right, in millimeters versus unit of umbrella being sold, right? And as the rainfall in millimeter, there is an increase, the units of umbrella sold are also increasing, right? So it's a linear relationship, right? The increase between these two variables. So So linear regression model was fit into the data to predict umbrella demand based on amount of rainfall, right? So if it is a linear relationship, so what is happening is you convert this into an equation, right? And how do you convert this into an equation? So for example, this is the equation, right? This is the relationship that has been created by the model, right? So what is the unit of umbrella sold going to be? Unit of umbrella sold in any month is going to be 120 into the predicted rainfall for that month plus 10, right? So if you remember in your college days or in your school days, you would have uh, worked with an equation called as y equal to mx plus c, right? Do you remember y equal to mx plus c, where y is your dependent variable, right? And x is your independent variable, right? Which is rainfall, right? Right? And what is your 10? Does somebody remember what was y equal to mx plus c, and what was the meaning of each of these elements in that equation? Okay, what is intercept, Joginder? What is meant by intercept? Okay, Deepti says constant intercept value of y at x equal to 0, right? The value of y when x is equal to 0. And what is 120 here? Coefficient, right? It is the gradient, right? So this has got converted into a linear equation, right? Where x is your independent variable, which is rainfall. So here you are trying to do, and now see, it's very different from time series forecasting, right? So you are not looking at historical sales data of how umbrellas have sold, right? You are What we are looking at is the interrelationship between what is the prediction of rainfall in future, and what is the correlation between the rainfall prediction and the umbrella sold in past, right? With the relationship between umbrella sold in past versus how was the rainfall, they have converted into this equation, right? Which is a regression equation, right? Now here the best fit. So what they have done is they have plotted these points, right? And what are these points? These points are number of umbrellas sold when a rainfall was 14 millimeter, right? What was the umbrella sold when rainfall was 6? So when they plotted these points, the best curve, right, on which maximum points lied, or the distance between the points and the line was minimum, was a linear line, right? Sometimes you can get different curves, right? You can get polynomial curves also, right? You can have a polynomial regression. So it's a linear regression. There you can have polynomial regression of order 2, order 3, right? Wherein this x become x rainfall square, rainfall cube, right? All of that, and you can have multiple coefficients, right? So it's a simple linear regression here, right, which is basis the strong correlationship that has been identified between an independent and a dependent variable, right? So causal methods are sophisticated tools for long-term forecast and demand turning point, right? The relationship between dependent and independent variables can be highly complex, right? Like I said, that multiple polynomial regression equations can also be generated. And the aim of regression is to find equation coefficients to minimize the sum of square deviation. This is a very important point, right? Why was the linear line selected here? Linear line was selected because most of the points were very closer to this line or on the line. So when we say most of the points were closer to the line or on the line, it means that the distance between those points and the prediction that is coming from this equation, that distance is minimum. And what is that distance? The distance is actually error, right? So for example, when I use this equation, let us say when rainfall was 18 millimeter, so what will be my prediction? 128 to 18 plus 10. Now 120 into 18 plus 10 will be a point on the line, but actuals could be above the line or below the line. So I can create the error. I can calculate the error, right? So the best fit, the best curve in regression is the one which minimizes the error, total error, when compared to all the actual points, right? So if let us say a polynomial curve is selected, or whatever curve is selected, that curve is selected basis the minimized error right, which that equation or that curve is giving, right? So this is what is regression, right? A very simple example of a linear regression, right? The second example is econometric model, right? And in econometric model, lot of variables are involved, right? So economic variables are used to predict possible trends for econometric modeling, right? And econometric models are a series of interconnected regression equations, right? And this type of model provides better explanatory results than standard regression, right? So there will be a sensitivity, right, to each of, for example, there we looked at the relationship between umbrella and your rainfall, right, which happened in past. Here, for example, lot of variables are being looked at, you know, in forecasting a certain dependent variables. So here we are looking at consumer spending, household income, tax rate, interest rate, employment, right? And changes in all of these together are resulting into a change in the forecast, right? So when you look at all of these interplay, right? For example, one changes in all of these variables at the same point in time can lead to a combined impact on the forecast, right? So in econometric models, they try to understand, right, the interconnectedness between these variables to understand the sensitivity, right, on the impact when it comes to generating the forecast. Okay. The third model is the leading indicator model, right? And what is a leading indicator model? So there is something called as lag and lead indicators, right? So lead indicator is a indicator which changes first, right? Which changes first. It's a harbinger. What is a harbinger? Which brings in news, right? Advanced news, right? So if this indicator changes first, right, the rest of the factors follow its route, right? So for example, a leading indicator is an economic factor that changes before the rest of the economy start to change its direction, right? Now, leading indicators help market participants as well as policymakers foresee major change in the market, right? So the factor changes, right, with a certain lag, like I was mentioning, right? So when I was giving an example of the media, right? So media is a lead indicator, right? And the impact of media on the sales is happening with a certain lag, right? So if you can study the lead indicators, right, then you can bring the impact of the lead indicator on the forecast, right, with a certain gap, right? So that is called as leading indicator model, wherein you look at certain indicators to see what can be the anticipated impact on your forecast of any product. Okay. So what we had seen is host of models, right? Basis our discussion of yesterday and today and a live session one. We saw lot of methods, right? And we saw end-to-end process of generating a forecast, right? First defining the scope, then gathering the data, then doing a segmentation analysis. We looked at Nestle farm analysis, right? And then we go about doing forecasting. In the fourth step, we basis the analysis, we say which method we are going to work with. Is it going to be time series method? It is going to be causal method within time series, which model within causal, which method, right? Or are we going to go ahead with qualitative, or are we going to combine the output of various methods, right, to get one combined forecast, right? So there can be various approaches, right? When we decide to combine the forecast coming from two different routes, so you may say, okay, I will generate the forecast using causal also, I will generate the forecast using one of the time series methods also, and finally I'll combine both the output and take an average of it. That is called as ensemble forecasting, right? So wherein you combine the output of various models, right, to get the final output, right? So that is called as, I'll just write in the chat, and it is very famous when you use machine learning. So that is called ensemble forecasting, wherein you try to combine the output of various models, right? So we studied basically two types of models, two types of approaches. So time series and causal methods, right? And these are the key differences. So the model in time series, it uses only time-based information, right? For example, trend, series, seasonality, cyclicity level, right? And this method uses historical knowledge for a certain amount of time to evaluate the predicted outcome, right? It is useful in a similar, smaller critical scenario. When we talk about causal methods, it is more extensive in the number of variables interpreting the results of the prediction experiment, right? And this framework is effective in order to achieve a round prediction when many different components needs to be added to the analysis, right? So two very different approaches of generating a forecast, right? So how do you select a model? So one is that you simply look at the accuracy, or what you can do is that you can run all the available models for a given SKU and customer combination, like we had done in the previous example, wherein we generated the forecast using SMA2, SMA3, SMA5, then single exponential smoothing 0.8, single exponential smoothing 0.5, and then finally we picked up the model seasonal, the exponential smoothing with 0.8 as an alpha factor, because overall it was giving us the least error, right? Similarly, we can treat every SKU customer combination to all the possible models, right? And select the model which is giving us the best accuracy. But I said that best accuracy, or least error, or may not be the only criteria, right? You may have to look at the effectiveness, you may have to look at the effort involved, you may have to look at the explanatory part of the algorithm, right? There could be other softer aspects also which can play a big role in you selecting the right treatment or the right approach as a analyst, right? So while generating forecast, multiple forecast model algorithms are generated, right? Like I said, right? And the algorithms are analyzed to determine the optimal forecasting model, which gives you the least error, right? Different parameters are considered to test the effectiveness of the model, and the explanatory part, trust part, right? The reasonability part, right? Now, like I said, right, and yesterday when I was discussing some comments about demand planning, some comments about forecasting, if you remember, one of the comments that I made was consensus is required, right, in finalizing the forecast. While we say that there are a lot of statistics, there are a lot of machine learning based approaches available in the market, but we need consensus, right? And why do we need consensus? Yesterday we discussed, we need consensus for creating a buy-in, right? We need sales support, we need marketing support, right? There are certain limitations to statistical modeling, right? We cannot bring in all the possible information and digitize it, convert it into a required granularity, convert it into a required format so that a model can consume it, right? So there is a certain limitation which we can come across when we try to do statistic modeling or machine learning modeling, right? So that is why we need that human intervention, we need human judgment, right? Human intelligence. Okay, so one is limitation of statistics modeling. So while the statistical forecast provide a baseline, there are many business input that may still not be captured, right, which require people to give their inputs. Business plan and knowledge and inputs are those factors that are equally important to be included in the forecasting process. So consensus is complementing the process, right? But like I mentioned yesterday, one has to constantly monitor whether consensus is really adding value or not. If it erodes the value of your baseline forecast or the machine forecast, you have to be very cautious about it, and you have to take input from coming from sales marketing with a lot of caution, with a lot of scrutiny, right? And what is the consensus forecast process? You try to first generate a baseline from your statistics model, and on that baseline then you discuss the output with sales, marketing, finance, supply chain, and try to take their inputs and build on that baseline, right? If you find those inputs very relevant. Okay, so these are some of the two important elements. So one is, how do you go about selecting the right model when you have so many, and what is the importance of the consensus on the forecast? Okay, now I've been mentioning, right, that there are various solutions which are available in the market, right? And most of the time companies are not doing this exercise of forecasting, of data cleansing, of outlier detection, outlier treatment manually, because it takes a lot of time and organizations don't have that kind of time. And if machine can do it for you, if standard algorithms and standard solutions can do it for you in the market, why would you want to put your managerial talent behind doing this exercise, right? Because what they need to do are more value adding activities in terms of looking at the forecast and taking certain actions, taking certain decisions, right? So there are many solutions, and you have to look at various solutions in the market, right, to see which solution satisfy your needs the best, right? Not all solutions offer similar level of features. So how do we find out what are the leading solutions or what are the leading products, tech products available in the market, which does forecasting for you, right? And which has a lot of algorithm, which can select the best algorithm automatically, right? By looking at the least error over the test period, and various other features we'll see, right? So there is an organization called as Gartner. How many of you have heard of Gartner? How many of you have heard of Gartner? Okay, so you have most of you have heard of Gartner, right? So Gartner publishes every year something called as Magic Quadrant, right? And Magic Quadrant is published for a lot of things, right? So the one that you are seeing here is a Magic Quadrant for supply chain planning solutions, right? Similarly, you may see Magic Quadrant for a CRM. You can see Magic Quadrant for supply chain planning and platforms. So, you can see Magic Quadrant for business planning platforms, right? So they try to put all of these solutions which are there in the market in 2x2 box, and they call this 2x2 box as quadrant, and they classify four quadrants as leaders, visionaries, niche players, and challengers. And in a detailed document that they publish every year, they also define what do they mean by leaders, what do they mean by visionaries, what do they mean by challengers and niche players, and they also give description of each of the solutions to give their pros and cons, right? So if you look at this Magic Quadrant for 2021, right, which was published last year, you can see some of the leaders into this space. So Blue Yonder, Kinaxis, E2Open, Logility, right? These are all top leaders, and their solutions or their technology, their expertise in supply chain planning is that of a leader. Then you see visionaries. So in visionaries, you see O9 Solutions, Arkiva, right? Then in niche players, you see Anaplan, Tools Group, right? So these are let me tell you what all solutions that I have worked, right? So I worked with Blue Yonder, I worked on O9 Solutions, I worked on Anaplan, I worked on Infor, I worked on SAP, right? So you will see here almost 15, 20, right? But not sure if one can get to work on all of these solutions, but here you can see, right, what are the platforms, right? Now, one case study, what I'm showing to you is, one of my previous companies wherein they were at a similar situation. So they had no forecasting software. They were doing everything in Excel file, in presentations, in PDFs, everything. And they wanted to transform their forecasting process, end-to-end forecasting consensus process. And they said that the tool that we want, the technology that we want, should help us do all of this, right? Now look at their requirement. The tool should be able to create a forecasting strategy by channel. Every channel should have a specific customized forecasting strategy. Okay. The tool should help them do consensus demand planning, which means that there should be a workflow automation wherein marketing can look at forecast, give their input, sales can look at forecast, give their input in the tool, so that their inputs are visible to everyone in the organization, and it is no more business of PPT and Excel, right? The tool should help them create what if scenarios, multiple scenarios. What if COVID hits? What if COVID is a mild COVID, serious COVID? What if stock in trade is high? What if sell-in, we want to do more? What is the impact of more sell-in on stock in trade, right? The tool should be able to do multiple levels of aggregation and disaggregation automatically. So if they change a forecast at national level, that national level forecast should get disaggregated at a CFA level forecast automatically using a disaggregation, logic. And aggregation anyways, there's only one way to aggregate, addition, but there can be multiple ways of disaggregation, right? The tool should have number of algorithms, and tool should auto select the best fit algorithm. It should not be planner's job. It should not be analyst's job of selecting the best fit. Tool should have a capability of trying all the available algorithms on a SKU customer combination, and the algorithm which is giving the least error should be the one which should get automatically selected, whether it is time series, whether it is causal, whether it is whatever. Okay, the tool should be able to support the product life cycle. So if it is a new launch, then algorithms which are created for new launch should be picked up. If it is a growth SKU, after new launch, the next stage is growth, then right algorithm should be selected. The third stage is maturity. The product has become mature. Then relevant algorithm should be picked up. If it is end of life, phase out, then different algorithm should be selected. Cross enterprise collaboration, right? Demand sensing. We had discussed earlier what is meant by demand sensing, which is to use short-term demand signals to generate forecast on a weekly or a daily basis, right? The tool should help them to do promotional planning. The tool should be able to tell them that if you do promotion, if you do media, if you do trade scheme, if you do this, if you do that, you can expect this much uplift on your baseline demand, right? So that promotion, uplift calculation, planning, everything should tool should help. And tools should also help them drive analytics, right? So you can see advanced analytics and reporting. What was the forecast accuracy? What were the top 10 candidates? What were the bottom top candidates, with lowest accuracy? What was the forecast last cycle? What is the forecast this cycle? All kind of analytics dashboard should be supported by this tool. So then they went about looking at so many platforms. They looked at JDA, which is Blue Yonder now, then Kinaxis, SAP IBP, O9, Anaplan, Saddlepoint, PlanVisar, which is from EY Consulting, and they mapped which platform fulfill their requirements. So whatever is completely black means that all these planning platforms, fulfill this requirement. Whatever is partially black or half black, it supports, but it supports that requirement partly, right? So here, if you see, total functional requirement, O9 was supporting the best. Then most of the others were doing it partly, right? So this is the framework. Now, for example, in your organization, you may not want what if scenarios. You may not want promotional planning, right? So each organization requirement will be different, and you have to see and assess using a similar framework, that which technology out there, which platform out there will best meet your requirements. What I'm not mentioning here, or what I'm not covering here, is the cost, right? Now your organization may have a certain budget as well, right? A certain cost as well, that we can't go beyond this, right? So if you have that as a starting point, obviously some of them you may not even want to explore. For example, IBP is extremely costly, right? So you may don't want to assess IBP when it comes to any forecasting scope or whatever it is, right? So these are the solutions which are available in the market, right? And this is one framework that I had used, right, in one of my projects earlier, to select the best tool for the organization. And this is one example, right? One case study, and this is the real product. And this is the real product that I have, I was the project lead, and whatever you are seeing on the screen, I have worked on it, right? So this is one product of an organization currently being used, currently gone live, and you can see what all steps we have discussed are actually happening. Outlier correction, outlier setup, outlier review, segmentation setup, segmentation review, sell-in setup, sell-in review, forecast setup, forecast review, scenario planning, econ forecast, right? So many capabilities are built into this tool. So what I'm showing you here is only one view, one screen, which is forecast setup, right? Now you can see in the forecast setup, we have created so many rules, right? So if there is an SKU, which is intermittent, which has a coefficient of variation, right? Let's say, let's look at this particular rule 6, right? So there's an SKU which has no intermittency, product life cycle is mature, coefficient of variation is Y class, volume segment is ABC, there's a trend, but there's no seasonality. So these are the available algorithms in the tool. So auto ARIMA, S ARIMA, triple exponential smoothing, multi AR NNet, artificial neural network. Then there is some TSLM, right? Then moving average. So you can see, while we studied only simple moving average and single exponential smoothing, you can see DES, which is double exponential smoothing, TES is triple exponential smoothing, knife, random walk, right? ARIMA, in ARIMA there are S ARIMA and auto ARIMA, right? Multi ARIMA neural network, right? There's something called TSLM also. So there are almost from 20-25 algorithms available, and this planning platform is selecting automatically the best algorithm, which will, for example, if there's any product, so first they are doing segmentation. So if there's any product which falls into this category, the rule 7 will apply. Now rule 7 has got so many algorithms. So what this model platform will do, they will try to calculate the forecast from all these models for SQs under rule 7, and whichever model will give the least accuracy for a given test period will be selected. Are you all getting this? This is real stuff in action. Are you all getting this? Yeah. And my planners, my organization, right? So most of the workflow and demand planning has been automated, but lot of analytics has gone behind creating this or designing this, right? Making this as a sustainable thing for the organization. Okay. So let's summarize, right? Demand forecasting. So simple moving average is the simplest and popular forecasting technique, right? Which is on the principle that the near past is the great estimator of the future. In exponential smoothing, forecast are the weighted averages of previous measurements, right? ARIMA corrects its own previous deviations from the mean data. Causal method believes that predictor variable has a cause and effect relationship with the independent variables, right? Econometric modeling takes into account many such predictor variables, right? And leading indicator is a method wherein one of the indicators changes first, and it has an impact on your product forecast with a certain lag. So if you have access to such indicators, prior information, if you get, you can use that information to build impact on your forecast, right? So these are various methods, right, which one should have an understanding of, right? If you're working on, for example, the project that I had worked on, it's a 3 years project, right? So if I had to design such a big planning platform, I need to have understanding of how these things work, right? I need to know what is the meaning of outlier setup, outlier review, what do we do in this step, right? What value does it add? So you need to have all of this understanding to drive such big analytics driven projects, right? Okay. And so this is, we are concluding forecasting, right? And we will now enter into inventory management, which is our second vertical, right? But one of a very decent books, right, which I personally like, and if you are, any one of you are interested, it's a quick read and a quick read, and it is available for free, right? So you can, and Rob J. Hindman is a very famous person in line of forecasting, in area of forecasting. So you can refer to this book called a Forecasting Principles and Practice, right? It's a very simple, it's a very easy to understand book, and I think you can complete this book in about 2 to 3 hours. Okay. So now we will enter into inventory optimization. Okay, so we have covered session 1, session 2 content, and now we will talk about inventory management and inventory optimization. Okay, so it is 12:08. So let's take break, and once we come back from the break, we continue with our discussion. Okay, so it is almost 12:10. So let's take a 10 minutes break and reconvene at 12:20. Okay, is it okay? Okay, so let's connect at 12:20. Okay. Hi everyone. Are all of you back now? Okay. 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 So let's continue our discussion, right? So now we formally enter into the second vertical, right? So we said we are going to look at in this course three key areas of supply chain and operations management, right? And see how various aspects of analytics helps drive important decisions, right? So we have already seen demand forecasting, right, which is one of the very critical areas, right? And the whole idea is to get an accurate forecast, right? Because, and we will see in inventory management how strongly and how closely it is linked with the demand forecast, right? And if demand forecast is of poor quality, is of poor is coming from a poor process using a shabby set of data, it can impact inventory management as a process. And inventory, once it is out of control, it can impact customer satisfaction, it can impact organization profitability, it can lock working capital of your organization, right? And the issues can grow into much bigger and much larger issues which are very difficult to handle, right? So we have seen various aspects of analytics related to demand forecasting, right? Now we will see how analytics helps us drive some important decisions around inventory management. And when we talk about these decisions being driven around inventory management, there are some questions that functional team or the business team has to answer, right? And what are these standard questions around inventory management, right? Inventory management questions are: how much inventory should we have? At what nodes or what points of supply chain we should carry inventory, right? When should inventory be ordered, right? And when inventory is being ordered, how much quantity should be ordered, right? Should we maintain the same amount of inventory for all the SKUs, right? Or should we have a differential policy given the kind of SKU that we are dealing with, right? How much safety stock should we have? How much cycle stock should we have, right? And why are we asking so many questions around inventory in terms of how much to order, how much to keep, when to order, right? Should we order or should we keep safety stock, for all the SKUs in a similar fashion? Because inventory is equal to money. Inventory, simply put, is equal to money, right? When we talk about inventory, we mean raw material, we mean packaging material, we mean indirect material, we mean WIP, we mean finished good, we mean material which is in transit, right? All of this is inventory. And for inventory, you have to spend money. You have to spend money to buy raw material, you have to spend money to buy packaging material, you have to spend money to convert raw material, packaging material into finished goods, right? You have to spend money in moving inventory from one place to another place. You have to spend money in buying insurance to keep your inventory safe, right? So it's all money. So if you end up having lot of inventory than required to run your operations, your money is locked, right? And that money had a potential of earning interest, that money had a potential of earning some return, which is now locked in your inventory, right? On the other side, if you have less inventory to support your business, you will be facing opportunity losses, right? You may not have stock to satisfy consumer or customer need. And if you are not able to satisfy that need for a long period of time, customers can eventually move away from you to some other competition, right? And they may never come back, right? So inventory is such a tricky topic, a tricky area to manage, that there's a very big trade-off involved, right? And the trade-off is between cost versus service level. If you hold too much of inventory, your service levels can be great, but your working capital has gone for a toss. If you hold too less inventory, your service level can go for a toss while your working capital. So there is a big trade-off involved, and you have to strike the right balance between what inventory you should carry at various parts of or nodes of supply chain versus the service levels that you are targeting. And when we say service levels, what kind of service you want to provide to your consumer? Do you all the time want to meet their order requirement 100% of the time, or you're okay with 5% of the time orders not being fulfilled or not being serviced, right? So we are going to look at all of these, questions, all of these aspects around inventory management, and how analytics, how some tools and framework in analytics helps drive this decision making process, right? So we are going to look at two aspects: inventory management and inventory optimization. In inventory management, we are first going to introduce what inventory management is about. We are going to look at inventory segmentation techniques. Like we had seen some segmentation techniques in demand, wherein we are segmenting A class, B class, C class, X, Y, Z. We segmented, looked at one segmentation example of Nestle Farm, right? Wherein basis contribution to business and the coefficient of variability, the SKUs were being segmented into mad bulls, jackrabbits, horses, right, and turtles, right? Now, in a similar way, we can segment inventory also. And why are we every time talking about segmenting SKUs when it comes to forecasting, segmenting SKUs when it comes to inventory management? Because we don't want to focus or channelize our energy, our resources in a democratic way on all SKUs. And that makes sense, right? Because not every SKU is contributing equally to your business. Some of these SKUs are very important, they contribute to 80% of your business, and hence you want to focus a lot more than 10% or 20% of your catalog or your offering, right? So that is why when you talk about inventory management, inventory, tactics, inventory strategy, you want to clearly know what are your hero SKUs, who are the SKUs which are hero for you, right? And how do you identify your hero SKUs? There are various segmentation techniques. So one segmentation technique that we had already seen is ABC segmentation. We have already seen XYZ segmentation, right, which is dependent on coefficient of variation. We're going to look at two more segmentation techniques, which is VED classification and FSN classification, and see what it means. And what is more important is to understand the actions or decisions that we are taking basis this segmentation, right? So you would have seen in Nestle case that once they segmented and once they identified what mad bulls are, they took action to convert mad bulls into predictable animals, right? So what are we going to do basis the results that come out of these segmentations is going to be our discussion. Then we'll talk about a very important aspect in inventory, which is called a safety stock. What safety stock is, why do we need safety stock, what safety stock, in terms of role it plays, how do we calculate safety stock, how much safety stock do we require, right? So all of this is going to be part of our inventory management discussion. And then we will talk about inventory optimization, which is to optimize, right, the inventory ordering, right? How do we calculate economic order quantity, right? What is meant by total cost of ownership when we calculate the impact of holding an inventory or ordering an inventory from a particular supplier. And then we'll conclude by looking at the need for supplier evaluation, right? So let's straight away jump into inventory management, right? So before we get into the specific topics, first I want to discuss some basics, right? So you would have seen my approach in demand management as well, wherein first I clarified some of the basics around demand, right? Various elements about demand management, demand shaping, demand forecast, demand plan, right? Then some rules about demand planning, forecast being accurate at aggregated level, forecast being accurate at shorter, on shorter horizon, importance of consensus, the magnitude of error is what matters in the forecast. And likewise, there were some 7 or 8 basic concepts for someone to, get a good grasp on before talking about time series, causal, and all of that, right? So similarly, we are going to look at some important concepts of inventory management, and I'm sure most of this you would have already seen in your supply chain and operations management course, but important for us to refresh this, right? So let's first look at the first important element, which is what is inventory, right? And I mentioned briefly, right? Inventory is the total amount of material. It could be raw material, it could be packaging material, it could be work in progress or work in process, it could be MRO. What is MRO? Anybody knows? Raw material, packaging material, WIP, finished good. This is clear, right? What is meant by MRO? Hello. Have you heard of this term in your Operation Supply Chain Management course, MRO? Yes. So Joginder is right. MRO is maintenance, repair, and operations, right? So obviously, see, so raw material and packaging material directly goes into your product, right? So it is part of bill of material of your product, but you also need some maintenance repair material to keep your machines, go on and on and on to produce for you, right? You need other materials also to keep your, manufacturing facility neat, clean, right? So all of these are consumables, right? Indirect materials which help you sustain or continue your operations. Even that is called as inventory, right? Because you have spent money in buying that and they are facilitating your set of operations and processes, right? So inventory is all of this: raw material, packaging material, WIP, MRO, and finished goods, right? Now, and why all of this is required? Because we want to convert raw material, packaging material to finished goods, sell it to consumers, get top line, get bottom line, and have profitable operations, right? Now, inflow of these, which is to receive all of these from suppliers, convert all of this into finished goods, right? Then carrying finished good from factories to warehouses, from warehouses to distributors, right? Which is outflow. So there's an inflow, there's an outflow in between, there's a storage also happening, there's a maintenance also happening. All of these operations involved in inflow, outflow, and storage of this inventory, which is raw material, packaging material, WIP, finished good, MRO, is called as inventory management. Okay. Now, third point is inventory is equal to cost is equal to money. In one equation, I have equated inventory to be equal to cost and money. Can someone explain this equation? What is the meaning of inventory equal to cost equal to money? So what is the meaning of this equation? Anyone? Okay. So Pallavi is saying to store the inventory, which is a cost to company. Okay. So see, there is the timely inventory is money, excess inventory is cost. Okay, good. Okay. So see, when you are buying raw material, packaging material, or you're converting it into raw material, into finished good, it is a cost for you, right? It is a cost for you, cost for buying that, cost for converting that, right? It only becomes money when you are able to sell it to your distributor or to your consumer or to a partner downstream, right? It doesn't, it is not money if you are not able to sell it. It remains as a cost for you, and hence it is very important. Do you want your inventory to spend more time here in this place, or you want quickly this inventory to move to this direction? You quickly want inventory to move from cost to being money for you, right? Right. What also matters is the speed with which you convert this into speed, right? If there's a delay in, let's say, converting this into money, will it impact this? Let us say there is a lag between your inventory being sold to any distributor or customer. Will the chances of this getting converted into money also lessen or also reduce, right? Because there is a perishability, right? There's a shelf life of your inventory. If there's a delay in converting this inventory from cost to money, that can also become a big implication, right? So in this equation, inventory can mean cost for you. If you're not able to sell, it can mean money for you, if you are able to sell it. And it can also mean money, but less money if you delay, right? If you delay it, in selling it to your consumer or customer, right? It can also mean more cost to you, right? If you're not able to sell, because for that much longer time you have to keep inventory with you, that much longer time you have to get the insurance done, that much longer time you have to move this inventory possibly from one place to another place, right? So it is a very important concept to be understood why so many organizations are finicky. They are mad about keeping inventory in control. They want to keep less and less inventory to give maximum service levels to their customer and consumer, because they understand the importance of inventory, carrying excess or short inventory, right? And all of you would have seen the impact of this in your HBR simulation, also in your previous course. The impact of keeping more and less inventory in case of model A and model B of your mobile phones, right? You had taken a hit in terms of cost, liquidation cost, right? And opportunity cost. Do you remember the implication of keeping less or going out of stock and having excess inventory? Do you all remember in your HBR simulation, global simulation V2? Yeah, in your production room. Okay. So now let's come to other set of basics, right? Inventory management. Why someone holds inventory, right? So there are various reasons, right? So one reason is economy of scale, right? So when you buy in bulk, and this economy of scale can be a proactive step or it could be a forced step. What is meant by proactive? You want to leverage economy of scale, which is when you buy in bulk any raw material or packaging material or any other material, supplier can offer you a discount, right? Sometimes as a manufacturer we lure or we give incentives to distributors to buy in bulk, right? We give quantity purchase schemes, so economy of scale can kick in, right? So we are looking at benefits. So first, let's talk about voluntary actions taken to reap these benefits, right? So economy of scale gives kick in, and your net unit cost comes down, right? Or net kg or net ml cost come down. Production, there's a smooth flow. What is the meaning of production goes smoothly when you hold inventory? So because there could be a variability from the supplier end, right? Variability from the supplier end can come from many fronts, right? So either supplier can delay the shipment, or the shipment that has been sent by supplier, has quality issues. The quality department has rejected the incoming, right? So if there is a delay or if there is a quality issue, right, you cannot afford to stop your production. You cannot afford to stop your lines and have an idle capacity, because it will bring your productivity down, first of all. Secondly, if your production comes to a halt, you are losing time, right? Consumer is not stopping consuming your goods, right? So you can come across cases where you can go out of stock, right? So if you keep inventory as a buffer, it can help you take care of the variability that can come from supplier and in terms of delay, in terms of bad quality. The other variability that can come from supplier is the short quantity, right? Supplier has sent stocks on time, supplier has sent good quality stock, but it's a short shipment, right? So now you are staring at a risk, right? So this buffer that you keep of raw material, packaging material, or any spare parts or any other material helps you run your production smoothly, right? It helps you take care of your sudden spike in sales, right? So production, we are mostly talking about raw material, packaging material. When we talk about sales, we are talking about finished good. So if you keep optimum inventory, if you keep safety stock, right, it helps you take care of the variability on both sides. So it helps you take care of variability from the demand side, it helps you take care of the variability from supply side, right? So even sometimes factories can throw surprises to you. They were doing production, but the production line or the manufacturing line, they faced some issue, right? So they had to stop the line, and they now will not be able to send you the shipment on time. Or the finished good which got produced had an MRP issue, or let's say it had a quality issue, right? So there could be host of variabilities in lead time, right, in quantity that can come in. Similarly, there can be host of variabilities which can come from demand side, right? So inventory has to take care of all of that, right? Other benefits, obviously, it helps you maintain, balance, reconcile demand and supply. It also helps you maintain adequate cash flow, right? Because if you have inventory, you will be able to sell that inventory, right, regardless of what variabilities are coming, and you are able to sustain your business, right? Now let's look at some of the other important concepts, right? Like I said, that there are a lot of decisions one has to take, and these decisions have to be driven via analytics. This decision has to set of decision has to be driven by looking at data, by looking at segmentation, by looking at certain calculations, right? And these decisions, like I mentioned, are around, what inventory levels you should have at various nodes of supply chain, when to order, what quantity to order, right? All of that. Now, some of the factors that you take into account, and we will look at some calculations later on. What inventory levels you should have to sustain your business depends upon the source. And why source? Whether it is coming from India supplier, whether it is coming from international supplier. The moment we say local or international supplier, what we are talking about is lead time, right? So if lead time involved is higher, you will have to keep much higher inventories. If lead time is shorter, you can keep much lower inventory to sustain your operation. Shelf life, right? If you're dealing with a raw material which has a shelf life of 1 week, you cannot keep more than 1 week of raw material, right? If you have a shelf life, if your raw material has a shelf life of 2 years, you can keep more raw material to take benefit of economy of scale, right? So shelf life of raw material, shelf life of finished good, right? For example, even when, let's say, we are in a shoes of consumer, right? And let's say milk has a shelf life of 1 day, right? And your consumption is 1 liter milk per day. Do you buy 3 liters milk every day? If your consumption is 1 liter and milk shelf life is only 1 day, will you buy 3 liters milk every day? Can you buy 3 liters milk every day? No, right? Because my consumption is only 1 liter and shelf life is only 1 day. So after today, your both packets will be useless, right? So what inventory you can keep of milk at your home is now dependent upon the shelf life. If let us say milk had a shelf life of 7 days, you can keep 3 liters milk, right? Every day, right? Let's say your milkman is servicing you every third day. The milk replenishment in your house is happening every third day, and your milk has a shelf life of 7 days. So can you keep 3 liters milk with you? You can, right? Right. So your inventory level has now dependent upon the replenishment lead time and your shelf life, right? Okay. Now let's look at production batches. Sometimes there can be a constraint from the supplier end or from the manufacturer end or from any other vendor who is producing in minimum batch sizes, right? So let's say you want to uh, let's say you have a consumption of butter which is only 50 grams, right? So can you, or let me give you a different example. I mean, let's discuss butter only. So your consumption is only 25 grams, right? So can you go and buy 25 grams of butter, Amul butter? Your consumption is only 25 grams. Can you go, right? So maybe the minimum pack size which is available is that of 100 grams, right? So now you're constrained by the offering from the supplier, right? So even if your consumption is 25, you'll be holding 4 times of your requirement, right? So inventory levels depend upon from where it is coming, what is the shelf life, what is the minimum production batch size, what is the variation in lead time and demand, right? So lot of factors go into deciding the right inventory level, right? And we will see shortly by looking at certain examples. When we talk about process of inventory management, like I mentioned, we have to calculate optimum levels of inventory for obvious reasons, because carrying excess or carrying short inventory have implications on business. What kind of control we want to exert on the inventory? We can't have same policy, we can't have same level of monitoring, we can't have same level of focus on each and every SKU, right? So we need to have a degree of control basis a certain segment. That segment can be ABC, XYZ, FSN, VED, right? We will look at it. There has to be an inventory control system, how much to order, when to order, right? And we will look at a fixed quantity system and a fixed period system, right? And how these two systems differ from each other, right? How do you control inventory? For example, most of the time, and I don't know how many of you worked in manufacturing setup or warehousing setup, invariably many a times the system stock doesn't match with physical stock, right? So let's say system is showing, or warehouse management software or any inventory management software is showing this SKU has 100 units present in this warehouse, and when you go and check you will find 102 or maybe 99. So actual inventory is not matching, right? So how do you ensure that there is no gap between your physical inventory and system inventory? How frequently should you count or check inventory, right, is also part of your inventory management. Other concepts in inventory, right? Bill of material. So what is bill of material? Bill of material is the list of ingredients which go into manufacturing of a finished good, right? So it specifies every single item which is going into your finished good, packaging material, raw material. It also specifies the quantity, right? Does bill of material specify the recipe? Does bill of material specify the recipe, or does it specify only the ingredients and the quantity? Right, so bill of material doesn't specify the recipe. What is recipe? The stepwise process, right? It doesn't say what is the first step, what is it only specifies the list of items which are involved and the quantity which is involved to produce a minimum batch quantity, right? When we talk about inventory, we also talk about first in, first out, last in, first out. While it is not the scope of our this discussion, it is to say, and we understood that inventory is about inflow and outflow, right? So when you are doing outflow, how should the outflow happen? Should you first send out the inventory which has come first, or should you first send out the inventory which has come last, right? So all of these so Pratiksha, there's no straightforward answer, so there can be first in, first out also, last in, first out also, right? So sometimes organization, whatever is the last inventory, they keep closest to the docking station, right? So they may find it easier and they may find it faster to send out the inventory which has come last, right? And sometimes that happens to us, right? So for example, we are standing in a queue, and that queue, you are the last person, right? And there are 100 people in the queue, and all of a sudden a new counter opens. Who is the first person to go to that counter? The last person in the queue, right? Right. So whether it is first in, first out, or last in, first out, it depends upon the context, these requirement. Many organizations go with last in, first out, first in, first out, but again it has to be selected, right? If it is very seriously linked with shelf life, obviously then you have to first send out what has come first, right? Because otherwise its shelf life is eroding, right? And you don't want to end up with inventory which is near expiry, right? So there it will be first in, first out, right? Okay, when we talk about inventory records, we have to capture each and everything about inventory, we have to capture how much we have received, how much do we have in terms of requirement, how much do we have on hand, what is inventory in transit, right? All of these are required for our various calculations purpose, right? And you would have studied in your operations and supply chain management course a concept about supply planning or creating a supply plan, right? So when a supply plan is being created, you all have heard and studied about supply planning, right, in your supply chain operations management course previously. A supply plan is a response to demand plan, right? All of you remember that? Yeah. So in supply plan, what is that supply planner is doing? So supply planner looks at demand. Supply planner looks at current inventory. Supply planners look at in-transit inventory. Supply planners look at WIP, and he calculates the net requirement by taking into account what all inventory is already there. If your inventory records are not correct, even his net requirement calculation will be wrong, right? It is very important hence to have accurate inventory records about what you are receiving, what you have on hand, what is in transit, what is the requirement, right? To get an accurate estimate of your net requirement. Okay. Now I said inventory is not free. Inventory is equal to cost. Now inventory is not just cost about the product. It is not just the cost about raw material, packaging material, conversion cost, or the cost of goods sold. there are other associated costs with inventory, which makes it a tricky subject. What are the other associated costs? Ordering cost. When you order inventory, and if you're ordering inventory many a times in a month or many a times in a year, there are administration costs involved. With every single purchase order, there are people involved, there are time involved, there are administrative costs involved, there are movements involved, right? So if you do lot of ordering, right, so there is an increased ordering cost, carrying cost, right? You are carrying inventory, right? Or it is also called as holding cost. So you are when you carry inventory, you have to store it in your warehouse, you have to store it in your warehouse attached with your factory, and all of these spaces are not free, right? There's a rental, there is a associated cost which you are spending, right? So when you carry inventory, you have to pay storage cost, you have to pay maintenance cost, maybe you have to pay insurance cost, right? So there are these associated costs. Then after that, you have overstocking and understocking cost. So when you overstock, you have to sell that stock at a liquidation price, which could be even lesser than your cost of goods sold sometimes. So you end up making negative profit margin, right? Sometimes you will not be able to sell at all. So which means that everything goes to your zero bottom line, destruction, right? And even destruction is not free. You have to pay money to organizations, other organizations, to destroy goods on your behalf. Even they will charge for you, right? Charge you for the destruction. So when you overstock, there are associated costs. When you understock, there's an opportunity loss, right? So inventory is an extremely tricky subject, very closer to finance guys, very close to operations guys, very close to managing director of an organization, and they don't want to hold excess inventory, right? So these are some of the basic concepts, right? One needs to know before dwelling into another level of discussion. Now you can see there are two charts, right? Two graph pictures which I am showing here. So one is that of explaining safety stock, right? So what you see here in this picture, right, is a so what you see the ship, imagine the ship as a customer order, right? And your responsibility is to sail customer order as smoothly as possible to make it reach from one end of shore to another end, right? So customer order has come and you want to execute it successfully, right? Now to execute a customer order which is being presented here as a ship or as a yacht, you want to sail this very smoothly, but you can see some stones here, right? You can see some rocks here underneath, and all of these rocks can make it very difficult to fulfill that order. What are these rocks? The inventory is of poor quality, hence you cannot fulfill the order. The process is poor, right? You cannot fulfill the order, right? There are breakdowns, there are supply disruptions, you cannot fulfill the order, right? The order which has come is of very high quantity against which you do not have enough inventory to fulfill, right? It cannot be fulfilled, right? So there are various hurdles or obstacles which can stop this ship to sail, right? To bring this to another shore. So what is in blue is your safety stock. So if you have enough safety stock which can cover or compensate for these so-called disruption, it can still help your ship to sail, right, or order to get executed, right? So you have to, and there could be another picture wherein the blue line is here, right? For example, instead of having safety stock here, you can have a safety stock to this level, and your ship could be here, right? For example, now while your issues are only till this magnitude, but if you are carrying too much of safety stock, that will lock your capital, right? So you have to calculate an optimum amount of safety stock which can just about take care of all of these variations and still help you absorb all of the shocks and get the order to another shore, right? So this is visually to see how buffer stock or safety stock helps you address right these gaps, right? Another picture is again to show you, right? So there is a supply rate, right? There is a demand rate, right? And then there is a buffer, right? So your supply rate and your demand rate can be different, right? And what this buffer helps you is to take care of managing the different rates for supply and demand which is happening, right? So this is what we are balancing demand and supply, also can be seen as a analogy of water tank, right? So in water tank, you all of us have water tanks, right? I don't know if you don't have at this point in time, but earlier we used to have, right? At water tanks in the terrace of our houses, right? What was the purpose of that water tank? Maybe today also you have water tanks in your homes, right? What is the purpose of that water tank? What is the role of the water tank? It helps you. It helps you manage your demand, right? Store water, right? You keep it as a buffer, right? If your water supply was 100% most of the time, will you have water tank? If it can be guaranteed that you will never have a water issue, will you have a water tank? No, right? But we know that's not the reality. Sometimes we get messages from society, sometimes we get messages from elsewhere that water supply is going to be stopped for 8 hours, for 10 hours, right? Or they will say that there is some cleaning, which is being planned, so there will be no water, right? Sometimes the water which is coming directly can have contamination, right? So we know there is going to be a variability, right, in the supplies. Even if somebody guarantees, we know from our experience in the past that there can be irregularities, right? To take care of all of that, water tank helps us, you know act as a buffer, and it doesn't let impact our usage. So we have constant usage of water in terms of bathing requirements, cleansing requirements, right, drinking requirements, right? And all of that this water tank helps us maintain that usage even if there is going to be a water issue or a supply issue, right? Okay. So so this annotation happens on every slide. Is that the case? Okay. Okay, so let's look at one case study now, right? Why inventory is important, right? And why it is important to hold or keep the inventory in control, right? So this is an example of a retailer, right? And see, most of the times when we talk about inventory, more often than not, you will see the examples of retailers like Big Bazaar, retailers like Reliance being discussed, because there are only two important KPIs in the life of a supply chain manager, in the life of an manager or analyst, right? Can somebody tell me what are the two KPIs? They live and die only by those two KPIs in a retail environment. If you go to any retail environment, speak where they have only two KPIs, and those two KPIs are availability and cost. Availability and cost. They want to maximize one. They want to maximize availability, and they want to minimize cost. Are they not both of them opposing goals? At one end, they want to maximize the availability so that whenever a customer is coming, they are able to provide the requirements and fulfill those requirements, right? That is meant by availability. But at the same time, they want to keep the cost very low to remain profitable. Are they not conflicting goals? They are, right. Hence, it is very important for them to ensure that they maximize the availability for the SKUs which matter to them, right? And minimize the cost, right? So very difficult to strike this balance. Like I said, that inventory management optimization is all about striking the balance between availability and cost, right? Okay, so let's look at this case study. So retail manager commit huge resources to inventory and risk management. Even with retail inventory representing 36% of total assets in a retail environment, about 36% of their assets are in form of inventory, right? nearly one of 6 items a retail store thinks it has available to its customer is not, which means their physical inventory and their actual inventory doesn't match, and which is 1 out of 6 items, right? Amazingly, close to two-thirds of inventory records are wrong. Failure to have product available is due to poor ordering, poor stocking, mislabeling, merchandise exchange errors, merchandise being in the wrong location. Despite being major investment in barcoding, RFID, and IT, the last 10 yards of retail inventory management is a disaster, right? Look at another challenge. The huge number and variety of stock keeping unit at the retail level adds complexity. And when we talk about Reliance Geo, Reliance Smart, or when we talk about Big Bazaar, right? When we talk about Easy Day or any other retail chain more, right? We are talking about lakhs of items. We are talking about hundred thousands of items, right? And we are not talking about 100 SKUs, and 50 SKUs or 1,000 SKUs, right? Imagine the immense complexity that gets added in retail environment. They Reliance sell, from vegetables to fruits to groceries to TVs, to gold items in the same location, right? You will find almost everything being sold there, right? So, and variety, if you want to go and buy, let us say, a soft drink, I don't know how many varieties of soft drink you will find there. If you want to go and buy noodles, you will have at least 10 brands selling noodles there, right? So does the customer really need 32 different offerings of a particular toothpaste or a 26 offerings of Colgate? Colgate itself is selling 26 variants of toothpaste to consumers, right? Proliferation of SKU, which is increase in the number of SKUs, it increases confusion, store size, purchasing, inventory, stocking cost, as well as subsequent markdown cost if you fail to sell any of these variants, right? With so many SKUs, stores have little space to stock. They have something called as backstore or a small warehouse, but again, it's a very premium space, right? It is a costly space. They can't convert it into a million square feet warehouse, right? So they have a very limited backstore space. And to display a full case of many product, it can lead to lot of issues in the backroom management as well, right? Super Value, it's a real retail chain. It is the fourth largest food retailer, right? Is reducing the number of SKUs by 25%. So they are now trying to rationalize the number of SKUs to bring inventory management in control, to as a way to cut cost, right? And it is also focusing on the self-branded or store-branded items. And you would notice if you go to DMart, if you go to Big Bazaar, if you go to Reliance, many grocery items are of their own brand, right? And how are they trying to control all of these issues around inventory management? They are trying to reduce the variation in delivery lead time. They are improving forecasting accuracy. They are trying to cut down on the huge variety of SKU to help drive inventory management in terms of cost and availability. Is this case study clear? Is this case study clear? What are the main levers? What are the main issues around inventory? How are they trying to address the large catalog and the other associated inventory issues with them? Pranjay, can you meanwhile float the feedback form?
Sure, sir.
Guys, is this case study clear? Okay. So, so while we continue, please take some time out in between to fill the feedback form as well. Okay. Okay. So with this case study, let's move ahead, right? Okay. So I said, like we have done demand segmentation, similarly, we have to also do inventory classification or inventory segmentation, because we cannot choose to have same amount of focus, same amount of energy on all types of SKUs, right? Because clearly we have some SKUs which will be contributing to 70 to 80% of our business because of Pareto principle or Pareto rule. So we have to design policies, we have to design inventory control management policies, right? how much to order, when to order, safety stock policy, calculation, everything basis a certain classification or segmentation, right? So when we talk about inventory classification, there are broadly 4 ways in which you can classify the inventory, segment the inventory. And each one of this classification takes or picks up a certain aspect, a certain characteristic, and build classification on that. And we have to look at specific situations to see which classification serves the purpose, right? So first classification is the ABC classification, right? So what happens in ABC classification? It helps or it takes into account the contribution to business, right? So we calculate the contribution to business, right, by multiplying the units being sold into the effective price of that product, and then rate in them into, you know, a certain order, you know, and then try to calculate the percentage contribution to business. So SKUs which contribute to about 80% of the business are called as A class SKUs, which are the top SKUs, right? SKUs which contribute to next 15% of the business are called as B class SKUs, and SKUs which contribute to last 5% of the business are called as C class SKUs. Now, most of the time you will see that the SKUs which are contributing to about 80% of the business will be 20% of the total number of SKUs. So for example, if you are selling 100 SKUs, most of the time you will find that 20 SKUs, top 20 SKUs are contributing to 80% of the business, right? And then 70% of your SKUs, right? So which is 70 SKUs, which are called as tail SKUs or long tail SKUs, are only contributing to 5%, right? So would you want to focus on 70% SKUs contributing to 5% of business, or you would want to focus on 20% SKUs contributing to 80% of your business? Where will you focus more? Where will you like to have more inventory and avoid going out of stock, in A class SKUs or C class SKUs? A class, right? And similarly, we had seen our forecasting strategy, right? Are we going to focus more on getting our A class forecast correct or C class forecast correct, right? We'll focus more on getting our A class forecast correct, right? So ABC classification really helps us, you know, classify and take some relevant calls, whether it belongs to inventory management, demand forecasting, right, or any other areas, right? Then second, and we will look at examples of each of these classifications. We are currently only looking at definitions. So the second classification is VED, which is we classify basis the consumption, right? So this is basis contribution to business. The second is basis the consumption, right? So basis the consumption, we can label or classify some materials as vital, non-negotiable, right? The second set of materials as essential, you know, still required but not vital. And third are desirable. Even if it is not there, it is not going to create havoc, right? So for example, in the month when we order grocery items for ourselves, there are some vital items without which we cannot sustain, right? So it could mean, you know, flour, wheat flour, it could mean, you know, pulses, it could mean, you know, spices. And there are some essential items, right? For example, it could mean floor cleaner, right? It could mean, you know, soap or any other thing. And then there are some desirables. Even if it is out of stock or doesn't come, it doesn't matter that much, right? It could be, for example, let's say a certain biscuit or a namkeen, right? They are not under vital or essentials, right? Similarly, the third classification technique could is FSN, which is fast moving, slow moving, and not moving, right? Now, FSN classification is different from ABC classification. ABC is contribution to business. Now, there can be certain SKUs which are highly priced. For example, their MRP is 5,000 rupees per unit. Now, even if they are selling less number of units, their contribution to business is high and they will get classified as A class. But they may be slow moving. Okay, so what is meant by fast moving, slow moving, and non moving is you may agree on a certain threshold to say if any SKU sell 2,000 units in a month, it will be called as a fast moving SKU. If anything which sells less than 2,000, between 1,000, it's called as slow moving. And if anything which sells below 1,000 is called as non moving, right? So ABC classification is based on the contribution to the business, and FSN classification is the rate at which it is being sold, right? The number of units being sold, or it could be around the velocity with which the products are being sold, right? The fourth classification or segmentation is called as XYZ segmentation, which is around variability, right? So, and we had seen this in demand forecasting also. So if the demand variability is under control, coefficient of variation is under control, we call it as X class. If it is middle variation, it is called as Y class. And if it is lot of variation, which makes prediction very difficult, right, which will require certain calls to be taken on inventory management as well, are called as D class SKUs, right? So basically there are four segmentations: ABC segmentation based on contribution to business, VED basis the consumption, right, criticality on the consumption on functional basis, FSNS basis the rate at which it is sold or consumed, and XY the classification is basis the demand variability. Okay, so let's quickly look at these definitions and we will look at some examples, right? So ABC classification, like I said, it is based on Pareto, right? And A category products, contribute to about 80% of the sales revenue, and the threshold can differ from company to company, right? So sometimes you may say, okay, 80% contributing to business, right? Sometimes you may say 70, whatever is contributing 75% and above to the business is A class. So ABC, it is not, it's a standard definition, but try and understand the principle here, which is called a vital few. What is vital few? Only few SKUs are important for you, right? And you want to focus on them, right? And the thresholds can be different, right? VD is basically criticality on functional basis, right? So, and let's see some of the definitions, some of the calls that the analyst will take basically classification, right? Due to high value of products in ABC classification, service level has to be defined accordingly for A category products. So what is the action that you will take for A class SKUs? You will choose service levels always to be very high because they are high contribution to the business, right? When you come to VED classification, which is vital, essential, and desirable, vital products are necessary for any business or customer. Their demands are more certain. Desirable product does not affect the function, demands are more uncertain. So what will you do? You will want to keep service level high for the vital products while low for the desirable products, right? When it comes to FSN classification, safety stock is optimized for fast moving products because they're moving very fast, right? While for non-moving products, you will not want to keep any safety stock because they are in first place not moving. And on top of that, if you keep any safety stock, it's a double whammy, right? So when you have to take a call on safety stock basis FSN classification, you will optimize it for fast moving and you will not keep it for non-moving, right? When it comes to XYZ classification, you will keep safety stock low for both X and Z category. Why low for X category? Because variability is less. So you will not need a tank, right? Because you are pretty sure that the demand is stable and I don't have to keep high safety stock, right? For Z class, the variability is high, but still you don't want to keep because you think it is useless, right? Because there is no limit to which you have to keep the safety stock. So that is why you will keep safety stock low in case of both X and Z category, right? And you will keep the safety stock highest for your Y class SKUs, right? Which is the middle variability, right? So there are four decisions which you will be taking on this classification of the inventory, right? So one is on the fill rate. So you will have to decide what fill rates you have to fulfill or provide basis a certain classification. You have to define a service level because basis the service level that you want to give in future, you have to carry that much of safety stock. So higher the service level, higher the safety stock, right? You have to take into account the lead time, right, between placing an order and receiving it, and it will also impact your safety stock calculation. And all of these three things are an input to safety stock calculation, which is the buffer to help you manage the uncertainty in both demand side and supply side. Okay, so we are discussing ABC analysis a little bit in detail, while we will look at examples of all the three levels of segmentation. Like I explained that ABC is a classification method. It based on Pareto principle. It helps on focusing on critical few or vital few rather than on trivial many. And breakdown of ABC category is not hard and fast, like I mentioned, right? It is not that 80% of the contributors will always be called as A class. You can do 75 plus and all of that. And sometimes in organization, they do A and A plus. So within A class also, they create a differentiation to say that, okay, A plus SKUs are those SKUs which are 90 and above, 90% and above. Okay, so you can do all of, but what main important thing is, objective is to try to separate the important from unimportant, right? So look at this. So almost 15% of your items are contributing to 80%. So you would obviously want to focus on this, right? And look at this part of your item which are only contributing to 5% of your business, which is a long tail, right? And how does it help you, right? It helps you, prioritize. So it helps, for example, purchasing resources expended on supplier development should be much higher for individual A items than for C items, right? So when it comes to sourcing or procurement, you are focusing more on suppliers who are providing you A items, right? Raw material, packaging material for A items. A items as opposed to B and C items should have tighter physical inventory control, right? They should be more secured. Their inventory records should be more frequently checked, periodically checked, right? Forecasting A items may warrant more care than forecasting other items, right? So if you forecast better, if you do better physical controls, there's a better supplier reliability, right? And an ultimate reduction in inventory, right, will be achieved with the help of such a classification. Okay. So let's look at one case study, and this case study again is from one of my earlier companies. And what are we trying to do with the help of this case study is to identify, right? So if you remember this example, wherein we were talking about the proliferation of SKU and it adding to the complexity, and even this organization was trying to reduce the number of SKUs. So how do we reduce the number of SKUs? Most probably maybe from C class, right? There could be some SKUs even from B or A class that can be identified as SKUs, which should be removed from the catalog. A company should stop selling, right? But how do we come to that list of SKUs which we should stop producing, which we should stop selling, right? Now this exercise is called as SKU rationalization exercise, and many evolved companies perform this exercise, maybe once in quarter, maybe once in 6 months, and they try to identify a list of SKUs which no more makes sense for an organization to sell, right? So let's see how one of the leading FMCG organizations attempt this exercise, right? So this exercise is called as catalog rationalization. They created a framework and they quantified the impact of having a tail SKU in system. So basically they are quantifying what is the impact of keeping an SKU, a tail SKU in system. And see, when, let us say, as a supply chain manager or as a supply chain analyst, you identify that list and you say, okay, we should not be selling these SKUs because these SKUs are not making sense. You have to justify that to sales, marketing, because they're still bringing some revenue to you, right? So they can take offense. They may get shocked when you bring such news to say, stop selling this SKU, right? So you have to bring analysis, such a convincing analysis in the front, so that eyes of sales and marketing people, finance people open wide and they say, yes, we should immediately stop selling this SKUs because they are not making sense, right? So how do you do that analysis, right? So you have to take into account a lot of parameters, right? So you have to look at contribution to business, you have to look at gross margin, you have to look at inventory turns, how fast inventory is rotating for that SKU. You have to look at demand variability, because if SKU is very difficult to predict, you have to spend efforts and money in getting the forecast right. You have to keep more inventory, more buffer stock, right? What is the production complexity involved in producing that SKU? Is there a minimum order quantity? Is there a minimum batch size? Is this SKU coming from mono source or multi source? Is this SKU coming from multiple locations? If it is coming from multiple locations, then supply chain complexity is manifold, right? What is the inventory quality of this SKU, right? So just see, in this framework, we are not only looking at contribution to business, we are also looking at gross margin, which is profitability. And gross margin is calculated after taking into account all the marketing spends, all the media spends, right? Everything which you are doing to sell that SKU. Maybe there is a scenario where contribution wise that SKU is an A class, but it is giving a negative gross margin. So profitability, it is negative, right? So when you create a catalog rationalization framework to manage your inventory, you have to take into account revenue, you have to take into account gross margin, you have to take into account supply chain complexity, you have to take into account marketing complexity, and create a cumulative 360-degree view to say whether it makes sense to sell this SKU in the market or not. Okay, so see what this organization did in terms of analysis, in terms of steps, right? So they took 2019 sales data at a SKU month level, they excluded free units. They first cleansed the data. They replaced all blanks with zeros after occurrence of a non-zero data point. They mapped SKU from catalog. They excluded, discontinued, and phased out SKU. They filtered SKUs with more than 6 data points, and this became the base for further working. So first they did data cleansing exercise, right? After that, they took SKU base, right? And in 2019 value they mapped, and they first mapped ABC status, right? How did they map ABC? If less than 80% contribution to business A class, between 80 to 95 B class, and whatever is contributing to only 5% of the business categorized as C class. After that they mapped XYZ status to show the demand volatility, right? So anything which has coefficient of variation at less than 0.3, they mapped it at X category. Anything which has coefficient of variation between 0.3 to 0.6, map it as Y category. Anything which is greater than coefficient of variation of 6.0, marked as this category. Then they mapped gross margin data at an SKU level, and they mapped this data given by finance, right? After that, they calculated the SKU inventory turns, right? How fast inventory is moving or inventory is rotating, right? After that, they assigned a rating, normalized rating, right? Because ABC is a different factor, XYZ. So if it is a class SKU, give it a score of 3. If it is a B class SKU, give it a score of 2. If it is a C class SKU, give it a score of 1. If it is an X class SKU, which is very good for supply chain, for organization, give it a score of 3. If it is a high gross margin, which is more than 60%, give it a score of 3. If it is 40 to 60%, give it a score of 2, right? Inventory turns, if more than 4, give it a score of 3. Higher the inventory turns, which means that higher is the inventory rotating, right? And then we club all the ratings. So we multiply all the ratings. So for example, the maximum rating one SKU can get will be what? What is the maximum score an SKU can get, and what is the minimum score an SKU can get in this framework? Can somebody say what is the maximum and what is the minimum score one SKU can get if we multiply all these ratings? Okay, so minimum rating is 1, right? So there could be an SKU which is C class, Z class, minimum gross margin, and minimum inventory turn, right? So 1 into 1 into 1 into 1, 1. And there could be an SKU which is A class, X class, maximum gross margin, and very good inventory turn. So 3 into 3 into 3 into 3, which is 81, right? So once you get these scores, right, for all the SKUs, you can filter out those SKUs, right, where your scores are minimum, right? And that becomes your initial list for discussion, right? Do you really want to build focus on those SKUs which are not contributing to business, which are very difficult to predict, which are having very low gross margin, whose inventory terms are also not great? Would you want to sell those SKUs in the market? Would you want to sell those SKUs in the market, which are most probably a headache for you, right? Most probably no, right? Yeah. So this is one example, right? One framework wherein different segmentations are being used to take a call of which SKUs to rationalize and which SKUs to not, right? It's a beautiful framework. It works nicely, right? And it is periodically used to bring up discussion with sales and marketing team to keep the catalog fresh and active, right? So we right now we will not go into safety stock, right? Let's be on a discussion related to segmentation, and let's look at quickly some of the examples on how do we do ABC, FSN, and XYZ segmentation, and how does it help, right? So let me just pull out the demo sheets. Yeah, Pallavi. So 81 and 1, you're right. So let me just pull out okay, so let me first let me know once my Excel file is visible to all of you. Is it visible? Okay, so this is a simple example of ABC analysis, right? So you can see category of the products mentioned, right? So let's filter, right? So you can see all sort of products are there: beverages, biscuit, chocolate, coffee, noodle, tea, chips and wafers. And these are the product descriptions, right? So these are from different brands, right? Britannia, right? Lay's, Ferrero, Nestle, okay. And you have product IDs, right? So what you have is unit cost for every product, and you have the average sales data, right? So what you have done is you have calculated the total, cost of it, or total, contribution. For example, 415 into 350, right? And after that, you have calculated the cumulative cost. What is the cumulative cost? Cumulative cost is this plus this, right? So 242 is the addition of this, and 328 is addition of this and this, right? So this is the cumulative cost, and you have calculated the contribution percentage, right? So for example, this SKU, right, when converted, when multiplied total number of units into it, unit cost or MRP, is contributing to 1 lakh, its contribution is 1,45,342, right? This contribution is 21%, right? The next SKU put together is contributing to 34%. The first three SKUs are contributing to 46%. First four SKUs are contributing to, so for that way, if you will see, what they have done is they have labeled those SKUs which are contributing to 80% of the business, right? And how many these SKUs are? 12, right? So let's write down. So what are these A class SKUs? These are 12 in numbers, and they're contributing to 80%. Now anything which is 80% to 95% is labeled as B class SKU, right? Okay. So let's see what are these SKUs. These are 23 SKUs, right? So let's look at these SKUs, B class SKUs. These are 22 in number, right? Which are between next 15%, right? So these are 22 in number. And then you have C class SKUs, which is the last 5%, right? So last 5% contribution to business are about 22, right? So if you look at this particular example, right, total number of SKUs, right? So even C class is around 22, right? So total number of SKUs in the example are 56. So A class total SKUs 21%, right? So basically, if you look at this analysis, about 20% of your SKUs are contributing to 80% of business. About 39% SKUs are contributing to 15% of your business. Last 39% SKUs are contributing to 5%. So here the spectrum is different, but you would really want to focus on these 12 SKUs, right, which are contributing high, right? Now, if you look at some observations right here, now, for example, look at this SKU, which is selling 385 units, but the MRP is less, and hence it has come to B class. But there are many such SKUs which are selling less than 385, right? So for example, this SKU is selling only 82 units, but because of high MRP, it has come under A class, because you are doing ABC analysis based on value to the business, right? So if you do a fast and slow moving analysis, maybe this SKU will be called as fast moving, but and this SKU could be called as a slow moving, because You may classify fast moving as someone who is, or some product which is selling more than 300 units, right? So that is how your ABC and XYZ analysis will differ, right? So this is one example of ABC analysis. Let us quickly see the analysis of FSN. Can you confirm if the Excel is visible for FSN? Is it visible, FSN analysis? Okay. Again, so here what we have in terms of product items or SKUs are all same items, right? And we have description, we have product ID, we have unit cost, and we also have a supplier, right? We have a lead time from the supplier, right? And this lead time is varying. So some is 5, 10, 15, 25, 30 days. And we have average sales of each of these products, right? Now what we have done is we have done classification of fast moving, right? Non-moving and slow moving. And what is the definition? If the average sales is more than 300, we call it as fast moving, right? If it is greater than 100, we call it as slow moving, else we call it as non-moving, right? So you can see, right, wherever the items are selling more than 300 units per month, regardless of whatever is the unit price, right? For example, here you will see that 120 is the MRP, but the products being sold are greater than 100, but less than 300, right? So it is come under slow moving, right? And whatever is less than 100, regardless of even MRP is higher, right? It could be called, for example, here the MRP is 100, but the sale is really less than 100 units, right? So it is being called as non-moving, right? So that is the difference between ABC and FSN analysis, okay? Now let's look at XYZ, okay? So I hope this is visible as well, right? So categories, products, ID, unit cost, suppliers, lead time, right? Now what you have is the historical data, right? You have historical data from September 19 to August 20. So this is 12 months of historical sales data with you. Now to calculate coefficient of variation, and what is coefficient of variation? It is standard deviation divided by mean, right? So standard deviation, you can see this Excel formula. So we are calculating standard deviation over 12 months. We are calculating mean over 12 months, dividing it, and then we have multiplied it by 100, okay, to get it in percentages. So how are we defining XYZ, right? So there is a, okay, so here they have not, okay, so this is, so there is a certain threshold, right? So while there are some standard, threshold which are available, for example, I said if coefficient of variation is less than 0.3, it is called as X class, right? But here they are using a little bit more stricter, approach. So here we can find out, right? So what is the threshold that they are using to classify X class, right, and Y class. So if we look at X class where the variability is low, so anything which, for example, less than 10% or coefficient of variation is the X class. So the coefficient of variation is basically the standard deviation, right, divided by mean, right? Now how should you understand this? If you look at any distribution curve, right, your mean is the center value and your standard deviation is the spread around mean, right? If the spread around mean is small or if it is less, right, which means that all values are closer to mean, which is easy prediction, right? But if your standard deviation is more, which is, the values around mean are very different, that means that it is very difficult to predict the value. So what it is doing here is it is dividing the standard deviation by mean to see whether they are closer values or whether they are far off values. If they are closer values, you will get a smaller factor, right? If, are you able to visually understand this, right? Yeah. So coefficient of, so now look at all of these data points, right? Now look at this case where coefficient of variation is 5%, right? Now look at the sales data. Look at the sales data. 800, 735, 724, 694, 79, 674, 700, 710, right? Now if you were to calculate, let us say average, average is 720. Now look at each of these values. Are they not very close to 720? 719, 725, 710, 711, right? Which means that this is fairly easy to predict. Is it not? Right? Now let us look at some Z-class SKU. Right? Now look at the examples here, right? Let us pick up this first example, 879. Now let's try and calculate the mean here. Right, 1000. Now look at the values, 1485, such a far value from 1000. 1291, right? Look at 791, right? Obviously, this is going to be more difficult to predict, is it not? Got it? Is it clear now? So coefficient of variation really helps you find out which is the easy or which is more predictable, right? And which is difficult to predict, right? Which is more easy to predict, there you will get more decent forecast accuracy, and there you have to keep less inventory because your forecast is going to be accurate. And where it is very difficult to predict, or it is Y class or V class, there you have to take certain calls. So all the three demonstrations are clear, ABC, FSN and XYZ. Hello guys. Okay. Okay. Okay, so I think the foundation is quite clear, right? And we are already 136. So let's stop here, right? And next time when we connect, so we are going to connect on Saturday. So we will continue from here, right? So we have discussed till here. So now we are going to look at how do we decide on reorder point? How do we decide on what safety stock to calculate, right? We're going to look at two models, right? We are going to look at few more examples, talk about ownership, supplier evaluation, right? So I think only 4 or 5 slides are pending, and we will also look at certain demonstrations. And once we complete inventory, then we will cover our network or the route optimization in our next class. Okay. So thank you everyone for being there on Sunday. And I look forward to meeting all of you on in our last live session, which will be on next Saturday. Okay, and we will anyways connect on following Tuesday to conclude our debriefing session or the simulation also. Okay, everyone. Bye. Bye. Pranjay, we can conclude.
Sure, sir.